Welcome to Amit Thinks YouTube channel. In this video course, learn C programming. C is a high-level language developed by Dennis Ritchie and introduced in the 1970s. The compilation and execution of a C program is quite fast. Some operating systems, tools and softwares, including device drivers, are still written in C. In this course, we have covered the following lessons with live running examples. Let's start with the first lesson. In this lesson, we will understand what is C, its introduction, features and applications. We will also see why we should learn C. Let us start. C is a high-level programming language developed in the early 1970s by Dennis Ritchie. C is known for its efficiency and control, which makes it ideal for system programming, such as developing operating systems, embedded systems, and other performance critical applications. Before C, B language was introduced. Okay, so Unix was written in C. The C language is having an extension of .c. That is, when we will create a C program later on, we will add an extension .c to the file. Now, why we should learn C? So if you are looking to work around C++ or Java or even Python, go for C first. Okay, it is a simple and reliable to use language. The basic programming concepts are covered in C language. So if you learn C, C++ and Java will be easier for you. Some device drivers, even packages and libraries, softwares and tools are still written in C. Since it is a fast and hassle-free programming language, let us see the features. So C is a language that enables code reusability and better organization. It can run on different machines with minimal changes. That is, it is portable. It is considered as a structured language, that is, you can easily split into multiple blocks of execution, that is called functions. Okay, functions allow you to encapsulate code into reusable units. That makes your code more modular and easier to understand. The execution of C programs is quite fast. It has a lot of built-in functions, okay, so that you can easily write complex programs. These built-in functions can be used for common tasks such as input, output, string manipulation and memory management. It also includes a rich set of operators for arithmetic, logic and bit manipulation. The code can be reused. It will eliminate the need to write the same code again and again. In turn, your LOC, that is the lines of code, will be less. Also, it has a concept of recursion in which a function calls itself, avoiding the need to write the code again and again. You can easily extend the C language. We can also extend its functionalities with libraries, macros. With that, various third-party libraries and tools are also available to extend C's capabilities, and it can also be integrated with other languages. Here are the real-life applications of C language. We all know that Python is one of the top choices for data science and machine learning. So some Python libraries are written in C, like the NumPy library. NumPy is used for data manipulation. Similarly, some operating systems like Windows and Mac are also written in C and C++. Linux is also written in C. Linux was developed by Linus Torvalds. Also, we know VS Code, right, which is developed by Microsoft. It's written in multiple programming languages. One of them includes C. Guys, we saw what is C, its importance, its features and why we should learn C. With that, we also saw some of the features and applications of the C language. Thank you for watching the video. In this lesson, we will see how we can set the C environment on VS Code. That is, we will see how to set up VS Code for running C language. Let us see the steps. To set up C on VS Code, first we will install a compiler that is known as MinGW. It is a free and open source C++ compiler. It allows you to create Microsoft applications using the GNU compiler collection, that is GCC, and other tools. So after installing MinGW, we will install VS Code. So what is VS Code? We'll be using VS Code to run all our C programs in this tutorial. It is a free and open source code editor which is developed by Microsoft. It's widely used by developers due to its powerful features, flexibility, and support for a wide variety of programming languages. So not only C, C++, you can also run Java, Python, CSS, JavaScript, and other languages on VS Code. It is available for Windows, Mac OS, and Linux. It provides smart code completions. With that, it is having a vast library of extensions that add functionalities such as themes, debuggers, and more. It is having syntax highlighting, intelligent code completion, and code refactoring also. So after installing VS Code, we will connect VS Code with C language. So let us start with the steps. We will see how to set up C or C++ on VS Code. For that, we will see the following steps. First, we will install the MinGW compiler to run C and C++. Then we will install VS Code. In the third step, we will connect both VS Code and C++. So let's see. Let us first install the MinGW compiler. At first, go to the web browser. On Google, type MinGW compiler and press enter. Now the first website, you need to click on it. Okay, here is the official website. I'll also add this link in the description of the video. Click the download button. Now the download will start. We have downloaded the exe file. Right click and click open to begin the installation. Minimize. Now the setup started. Click install. MinGW will get installed in the following location. Keep it as it is and click continue. Now the setup started. Let's wait. Click continue. Now the following is visible. Here and select the packages you need to install. First, I'll select the developer toolkit. Click mark for installation. Do the same for base. Mark for installation. And for G++, mark for installation, and Objective-C also. Click and mark for installation. Okay, rest keep as it is. And go to installation. Go to installation and click apply changes. Click apply. Now it will download the packages. It will take some good amount of minutes based on your internet connection. It's written all changes were applied successfully. Click close. Now we have installed it. Okay. Go to the location. It was in C drive. Remember, here it is, MinGW. Go to bin. Go here, right click and copy the path. Minimize. Go to start. Type environment variables. Edit the system environment variables and click open here. Now click environment variables. Here click path. Double click. Click new. Right click and paste the same path. After that click OK. OK. and the last OK. Now we have successfully installed it. Let us verify. Go to Start, type CMD, click Open. Now let us verify the installation. Type G++ space hyphen version and press enter. Here it is, it's visible. That means we successfully installed it. So guys, we successfully installed the MinGW compiler. Now in the second step, we will install VS Code on Windows 11. Let's start. At first, go to the web browser. On Google, type VS Code and press enter. Now the official website is visible, code.visualstudio.com. Click on it. Now here the version is visible, download for Windows. Click on it to download. Now the download started. Here it is. Here is the version. Right click and click open to begin the installation. Minimize. Now click I accept the agreement and click next. Here is the location where VS Code will get installed. Click next. It will create a start menu folder. Click next. Additional task, if you want a desktop icon, you can select this, but I don't need it. So I'll keep it as it is and click next. Now the summary is visible. Click install. Now the installation started. Let's wait. The VS Code setup completed. Click finish and it will launch on its own because the checkbox is by default clicked. I'll click finish. So VS Code opened for the first time. So guys, we successfully installed VS Code. Now in the third step, we will connect both VS Code and C++. To connect VS Code with C, click extensions. Now here type C++. Now you need to click on the extension pack. Click on it. Here the installation button is visible and it is officially provided by Microsoft. Click install. We have successfully installed it. Okay. So this is how you can connect C and C++ with VS Code. So guys, we saw how we can easily set the C environment on VS Code. Now we have connected our VS Code with the C language. In the next lesson, we will run our first C program. We will create our first C file on VS Code with the extension .c. We will write a C code in that file and also run it successfully on VS Code. Thank you for watching the video. In this lesson, we will see how to run our first program in C language. So in the previous lesson, we saw how to set up C on VS Code. We also installed the MinGW compiler. Now we will use them to run our first program. Okay, so when we will write our first program on VS Code, the following will be used. The first one is hash include. The pound sign, that is the hash, is for preprocessor. So this is the first thing which will be read by the compiler when we will compile the program. After that comes your header file. In this case, we will use stdio that allows performing input-output operations such as printing to the console. So we will print a text as an output. Then your main function, as the name suggests, the main, okay, the key function, the main function where the program execution begins. Here the int before main indicates that the main function returns an integer value. Here int is the return value. Then we will use printf. This is a method. Consider this will allow you to print the specified string to the output. The printf is a built-in function provided by C language. In the end, it will return. That means the function execution will get terminated, and this is a return statement. This will return the control to the calling function. That means the end of the program in layman language. Okay. Now we will run our first C program in VS Code. We will create a new C file with the extension .c. Okay, let's see. So we will see how to run our first C program on VS Code. For that, let us create a project folder. Go here. Click here. Okay. Now click open folder. Go to the desktop. Here let us create a new folder. Click here, new folder. Let's say the name of our project folder will be Amit project. Click on it and click select folder. Now let us create our first C file. You can right click here and click new file, or you can also click here. Can you see new file? Okay. I'll right click and click new file. Let us name the file demo. The file extension of a C file is .c, so I'll just mention the same. Here is our first file. Now let us write our first program. First we will add a header file that is used to include the standard input-output library. Okay, you can also add a space here. Now we will add the main function. Okay, this is the main function where the execution of the program begins. Now I'll print something using the printf method. This line prints the text on the console. Okay, now whatever you'll add inside this will print. So here I am printing Amit Diwan on the console. Add a semicolon. After that, type return 0. This indicates that the program executed successfully. Okay, now I need to click save. Here you can see a dot. Okay, that means you need to save the program. Go to file, click save. Now this dot will vanish. Okay, you saved your program. Now to run it, you can either go here and click run, or you can also use an alternative which will ease your work. Go to extensions. Here type code runner and press enter. Click the following. Okay, here it is, and just click install. We installed it. You can close it now. Okay, now I'll tell you the usage of this extension. After writing a program, right click and now you can see the run code. Okay, click. The exe file also generated. Okay, and here is your output. Okay, I told you printf will print the line on console, so it printed it on console Amit Diwan. So in this way you can run your first C program. So guys, we saw how we can run our first C program on VS Code. We successfully printed a text. Here we have used return 0 also, because this returns an exit status of 0 to indicate successful execution. Thank you for watching the video. In this lesson we will understand what are data types in C language. With that we will also see the data types used in C language. That would be really helpful for us in the upcoming lessons. Let us start. A data type is an attribute of data that tells the compiler or interpreter how the programmer intends to use the data. So consider data types as the kind of data that can be stored and manipulated within a program. The following are the two types of data types in C language: basic and derived. Let us understand them. Basic data types are the fundamental data types in C. Beginning with int, as the name suggests, int is integer. The int data type in C is used to store integer values, which are whole numbers without any decimal points. It is one of the fundamental data types provided by the C language and is widely used in various programming scenarios. Okay, it is used for integers, that is to store integer values. The size of int can vary depending on the system architecture, but it is typically 4 bytes, that is 32 bits on most modern systems. In the bottom, we have shown how to declare and initialize an integer variable. Int space num, int is the data type, num is the variable name, and the value after equal is 10, that is the num variable is initialized to 10. Okay, so this was an integer variable. Next comes float. Float is related to double, so let us understand them. Float and double are data types used to store floating point numbers, but they have different characteristics in terms of precision and memory usage. Float is used for single precision floating point numbers, whereas double is used for double precision floating point numbers. That means when you want higher precision, go for the double data type. The size of float is 4 bytes, whereas the size of double data type is 8 bytes. Float is suitable for applications where memory is constrained and the precision requirement is moderate, whereas double is preferred when higher precision is required. The memory usage of float is less than what double uses. Here is an example below. Using float and double, we have initialized two variables, float pi and double large number. Next is char. Char, as the name suggests, is for characters, that is to store single characters. It is one of the fundamental data types in C. Its size is typically 1 byte, that is 8 bits. It is used to store single characters such as letters and symbols. Strings in C are arrays of this char only, that is terminated by a null character. So we will work around these data types in the upcoming lessons in our programs. We will also use the char data type to create strings in C language. Here is an example in the end. Char space letter, letter is our variable here, and using this we have stored a single character A. So these were the basic data types in C language. Let us now see the derived data types. These are built from the basic data types only. They offer a unique way to store and manipulate data in C. Beginning with arrays, it is a collection of elements of the same type. Pointers store the memory address of another variable. Pointers allow you to directly interact with memory. They are variables that store memory addresses, typically the addresses of other variables. Structures used to group different data types into a single unit. So arrays for similar type, whereas structures are for different data types. Unions can be related with structures, but they share the same memory location for their members. So we will study all of them in the upcoming lessons. The last one is enumeration. It is a user-defined data type that consists of integral constants. Enum is short for enumeration. It consists of a set of named integer constants. It is used to assign names to the integral constants, which makes the code more readable and maintainable. In the upcoming lessons, we will study these basic and derived data types in the form of lessons, topics, and codes. So guys, in this lesson we saw what are data types in C language, what are its types. Thank you for watching the video. In this lesson we will understand what are format specifiers in C language. Let us start. Format specifiers in C are used in functions like printf and scanf to define the type of data input or output. they serve as placeholders within a string where values will be inserted or read. Here a table is being shown with the format specifier, the data type and the description. For integers we generally use %d. For characters %c. String is an array of character, so for that use %s. It's written string of characters, you can see. For float we use %f. Float is a floating point number. Double is having higher precision. For that we use %lf. Similarly we use other format specifiers. Like for unsigned decimal integer we use %u. For hexadecimal and octal we use %x and %o respectively. Let us see some examples to understand. Let's say you are declaring and initializing variables. Here we have declared first an integer variable, then a floating point, after that a double, and in the end a character, a single character. Okay. So when you will print it, to print in C, you need to add the format specifiers. Like to print the num is an integer variable. Here we have used the %g. Okay. For float we have used %f, but that is for the pi 3.14. But you can see %.2 here. Dot 2 is for precision. So after the decimal it is allowing only 2 digits. That's why the output will be 3.14 in this case. For the third one, that is double, we have used %lf. Similarly we have used .8 here. Like in float we used .2. .8lf means the format for printing a floating point number. The dot represents the precision, that is the number of digits to be printed after the decimal point. 8 specifies the precision, so 8 digits will be printed after the decimal point. LF stands for long float and is used for printing double type numbers in C. This means .8lf will print a double value with exactly 8 digits after the decimal point. So we have also shown the output. And the last, a single character, we have used %c. Okay. In this way guys, the format specifiers work in C language. Int, float, double, char are one of the most popular data types used in C language, and these are the format specifiers for them. So guys, we saw what are format specifiers in C language. It is mainly used in printf and scanf. So in the upcoming lessons we will frequently use them to print different types of data type values. Thank you for watching the video. In this lesson we will understand what are variables in C language. We will also see some naming conventions related to creating variables. With that, some examples will also be covered regarding creating variables. Let us start. Consider a variable in C as a symbolic name associated with a storage location in the computer's memory. That is the name given to locations in memory. Variables are used to store and manipulate data values during the execution of a program. So I just said locations in memory. So these locations can be integers, characters, even constants. Each variable in C must be declared with a specific data type. Now what is a data type? Data type is a type of data. For example, your roll number is an integer. Roll number can be 101. Price of a commodity can be a float. Price can be 50.5. This helps in determining the type of data the variable can hold. Let's see. So when you create a variable name, the first character must be an underscore or an alphabet. We are discussing the rules for naming a variable before covering an example. The first one, a variable name is a combination of alphabets, digits or underscores. So the valid variable names we have shown here to cover this point. That is, you can add a number also. in a variable name, that is val1. It can be a single letter like A, or you can also use underscores like result underscore marks to store the value of marks. Okay, other than underscore, you cannot use any of the symbol. That is, no special symbols are allowed except underscore. Below you can see the valid variable name and the invalid variable name. I just discussed the same. You cannot add any special character, so we can't add star, dollar or any other special character, but we can add underscore as displayed on the left. So these are the rules for naming a variable. More rules: you cannot include comma, blank space is not allowed. Try to create meaningful names. Let's say we want to get the marks, so keep the variable name as marks or results. Okay. Now let us see how to declare a variable. Consider this as creating a variable. The following is the syntax. You need to mention the data type, then the variable. Why it is written var list? That means you can add multiple variables here. We have given some examples below regarding the syntax. Int result, here int is the data type and result is the variable. Now the next one includes var list example, that means multiple variables in a single line. So we mentioned the int data type, then two variables in a single line, marks underscore 1 and marks underscore 2. So these were integers. Marks is an integer, so the int data type. Then came your char, that means adding a single character. So let's say you have assigned a code regarding a task, so you can mention it like this: char s is equal to p. Let's say the code name is p, so it's a single character, not a string. Okay, that's why we have included the char data type here. Then char name also you can add. Then came your points. Let's say you want to mention the point, let's say 1.50, 2.70, 3.75. You can add it under the float data type. That means float is the data type and points is the variable name. So these were some examples related to declaring a variable in C. We will now see an example. We just saw that how a variable is declared, how a data type precedes the variable name, right? Like int marks. Here we have shown that if you'll write int space marks, since it is marks, so it is an integer. We have assigned 100 to the marks. In this case, the variable assigned to location is marks. The value of the variable is 100, that gets stored at the location. And an address is also assigned. Here the address of a variable is a unique identifier that indicates where the variable is stored in the computer's memory. This is the memory address. These addresses are useful in various programming scenarios such as pointer manipulation, dynamic memory allocation and function arguments. We will see these things in the upcoming lessons. So let us see an example to create a variable on VS Code. This was our VS Code. Let us right click here and click new file to create a new C file. I'll name this demo2.c. Okay. Here it is, demo2.c, and I hope you remember the location. It was on the desktop, Amit project. Here it is, demo2 now. Okay. Now let us write a program like what we did in the first example. Okay, we will do the same. First the header file, then the main function. Now let us create a variable marks. So we have added the integer data type and variable marks. So I'll give it a value, let's say 100, and now I'll print it. Okay, using the printf method. Under the quote, mention whatever text you want, let's say marks or let's say maximum marks, and after that comma and mention the same variable. When I typed MA, it is showing us the marks here. Also mention a semicolon. and return 0. So this won't print anything. I'll show you why. Okay, go to file, click save. Now right click and run code. Can you see here? It did not print anything. Why? Because we haven't added the format specifier. So for integer, you have the format specifier %d. Okay. Similarly, for other data types, we have other format specifiers which we'll be covering in the upcoming lessons. Right now for integer, you have %d format specifier. Whenever you are adding an integer variable, you need to add %d. Now it will print. Go to file, click save, right click and run code. It printed the value 100. If you added 10, it would have printed 10. So we have printed the marks value. So in this way, guys, we can work around variables in C language. Go to file and save. Thank you for watching the video. In this lesson, we will understand what is a variable scope in C. We will also see the types with examples. Let us start. In C language, the scope of a variable determines where that variable is accessible within the code. So the region where the variable exists is called its scope. And while creating and working around the variables, these scopes really matter. There are mainly two types of variable scope in C language. The first one is local and the second one is global. So let us understand them one by one with examples. The first one, local. So a local variable is declared inside a function or a block and is accessible only within that function or block. Okay. It is created when the block is entered and destroyed when the block is exited. So to understand this, we will see an example where we will create and initialize local variables. With that, we will access them and also use it in our program. Let's see. Here is our VS Code. Let us create a new file. Under our project, right click, new file, demo3.c. Now we will create local variables. I'll add the header file. Then the main function. And now I'll declare 4 variables. Initialize. We have initialized the first 3 variables. Now S, let's say I'll multiply the first 3 and that's it. Okay. Now we will print it using the printf. P is equal to, I hope you remember, %d is the format specifier for integers. P, okay. Similarly, I'll do for rest of them. So I'll just copy, paste, okay, semicolon. Now I'll do this for Q and Q, R, and I'll also add this. What is this? This is /n for next line. So that after the value of P, in the next line we have Q, in the next line we have R, and in the next line we have the last result. Okay, that means S. So what is S here? S is the multiplication. Let's say I mentioned this. Okay, and here we have S. I hope this is fine. And return 0. Now we have 4 variables in local scope and we are printing it. That's it. File, save, right click, run code. So we printed it. Okay, PQRS S was the multiplication of 2, 5 and 7. That is 70. That's it. So this was local scope. Okay, within the scope. So we saw the local scope, that is local variable example. Now let us see what are global variables, that is global scope. A global variable is declared outside all functions and is accessible from any function within the same file. It is created when the program starts and destroyed when the program ends. Global, as the name suggests, means accessible from anywhere. We will see an example to create and work with global variables so that you can understand the global scope more. Let's see. Let us create a new file. Right click, new file, demo4.c. Okay. Now what we will do? We will take this example. We added local scope here. So I'll just right click and copy it completely. Right click and paste it. Okay. Now we have the same example. But what we will do? We will remove S here. And I'll add S above the main function to show you the example of global variables. Now this is a global variable and the following are local variables. Still we are able to access it, right? Because this is the advantage of using a global variable. The scope is global, accessible from anywhere. Now there won't be any error even when we have not declared S here. We are still using it. Let's see, go to file, click save, right click, run code. Now demo4, same example, S is above main and the output is perfect. It's correct. Okay. So this is how, guys, we can work around global variables. We saw both local and global variables with examples. Thank you for watching the video. In this lesson, we will understand how to get user input in C language. In the previous lessons, we saw how to print a variable value. Now let us see how to get an input from the user. With that, we will also see an example. Let's start. Handling user input in C involves using standard input functions provided by the C standard library. One of them is scanf. It is used to read the data input by the user on the console. It reads formatted input from the standard input, that is the keyboard. It's commonly used to read basic data types like integers, floats and characters. That is the data type we have discussed previously. Let us see some examples. So we will first run a C program to print an integer entered by the user. After that, in the second example, we will print the multiplication of integers entered by the user. Let's see. Here is a VS Code. Let us create a new file. Right click, new file, demo5.c. I'll first mention the header file, stdio.h, then the main function. Let us take an integer variable I. I'll use printf and mention enter a number. So this number will be entered by the user. That's why I printed enter a number. Okay. Now let us use the method which I just discussed, scanf, and we will add %d. If you remember, %d was a format specifier, and we will use and I to get the input. This and is an ampersand. This and is used to obtain the address of a variable and called the ampersand. So this line will give us the input entered by the user. So after getting it, we will print it. %d and the same I variable, because I will have the input provided by the user, which we will print it. We can also add a text /n for next line, the number entered by the user. Okay. That's it. Here an error is visible because we missed the semicolon. That's it. Return 0. File, save, right click, run code. Here you can see we cannot run it because it will run on terminal. So to fix it, go to file, go to preferences, then settings. From here type run in terminal. Under search and click code runner run in terminal. Okay, select this and close it. Now stop code run. Okay, after that I'll right click again and click run code. Now it's visible, enter a number, the same I told you. Okay, enter a number. Now mention, let's say I'll mention 50 and you need to press enter. And it automatically printed the number entered by the user is equal to 50 from here. Why there is an additional line? Because we mentioned /n. So we got the input from the user only and printed it on the terminal. So this was our first example to print an integer entered by the user. Now let us see an example to print the multiplication of integers entered by the user. Our second example, right click, new file, demo6.c. I'll quickly add the header file and the main function. Now I'll take three integer variables to get three numbers and an integer variable for the result. Okay. Now I'll use printf and enter the first number. That means I'll ask the user to enter the first number. Then scanf, %d like we did before, and here and a. Okay, so on the terminal it will ask the first number and under a the first number will get stored. Similarly for the second number, so I'll select and copy, paste and paste. So now we have all three. There is an error because we missed the semicolon, and here change the value b and the value c. Second number, third number. Okay. Under res, after getting the value of these three numbers by the user, under res multiply these three numbers and display it. So we are getting the numbers to multiply, and after that print it. That's it. %g, res. We have printed res, and here we can also add multiplication result. Okay, that's it. Go to file, save it. Okay, we will get ABC from the user and add it here to get the result, and we'll print it later on. Go to file, save, and return 0. That's it. Semicolon, we missed it. Now it looks fine. Go to file, save, and I'll run it. Right click, run code. It will automatically go to the terminal again because we selected it under the settings. First number 5, second number 10, press enter for the third number 15. Now what will happen when I'll press enter? It will multiply. And here it is 5, 10, 15. When multiplied, the result is 750 because we added this here. Guys, we saw how to get input from the user in C language. We used the built-in function scanf, and we also saw two examples. Thank you for watching the video. In this lesson, we will understand what are tokens in C language, The types of tokens will also be covered. Let's start. In C programming, tokens are the smallest units of a program that the compiler recognizes. Consider them as individual words and punctuation. They are the building blocks for constructing code and include keywords, identifiers, and white spaces. It also includes constants and operators. So here we'll be discussing three types of tokens, that is identifiers, keywords, and white space. Let us start. Identifiers are names used to identify variables, functions, arrays, and other user-defined items. Remember, you cannot use keywords as identifiers. Keywords are reserved words that have special meaning in C. We will discuss the concept of keywords later. So identifiers must begin with a letter or underscore and can contain letters, digits, and underscores, just like variables. The following are some examples of identifiers. Like we create variables, marks variable, it can also start with an underscore, like underscore marks, or a single character A. You can also add numbers in it, like study 987. Okay. With that, the number can be added in the end also, like result 1. So these are just examples of valid identifiers in C. Here are some rules for naming identifiers. As I said before, it can start with an underscore or a letter. It can include only letters, digits, or underscores. Except underscore, you cannot add any other special character. And it should never be a keyword. Like we used printf before. Printf was a keyword. So you cannot use printf here. And it should not contain any white space. Like we have shown before, you can add underscore. If you want to add marks result, you can add marks underscore result or result underscore marks. So white space is not allowed. Now let us see what are keywords. I just related identifiers with keywords, and I told that keywords are reserved words. So over 30 keywords are part of the C language. You cannot use keywords as identifiers, that is, you cannot add keywords as variable names or function names. Here is a list of keywords that are known to the C compiler. Some of these we will discuss in the upcoming lessons. We saw before int, char, float. So these are also reserved in C. That is, reserved words are called keywords in C. These are keywords in C language. Now let us see the third type, that is white space. So white space, as the name suggests, includes vertical tabs, horizontal tabs. It can be blank comments, end of line, and others. If you'll add a white space, then it won't be considered by the compiler. But you can still use white space in comments. We will discuss comments later also. Okay, and white spaces can be used to separate parts of statements, like I told before how to create a variable. When you write int space I, then the space, we are using white space here. Similarly here, float points. A float variable points. The data type float is separated by the variable name points. So this is also a part of tokens in C language. So guys, we saw what are tokens in C language. Tokens are smallest units of a program that the compiler recognizes. We also saw some types of tokens like keywords, identifiers, and white space. Thank you for watching the video. In this lesson, we will understand what are constants in C. With that, we will also see its types and examples. Let us start. In C programming, constants are fixed values that do not change during the execution of a program. So these values cannot be modified once they are defined. They are also known as literals. Constants can be of various types such as integer, real, character, and others. So let us understand these types of constants with examples. Let us start with integer constants. So these are whole numbers without any fractional and decimal part. That means it cannot have a decimal point and it cannot even have an exponent part. There are some rules to create integer constants in C. As I said before, it won't include any decimal point. It should have at least one digit in the integer constant, like digit 7, digit 20. It can be positive or negative. That means 20 or minus 20, 10, 23, minus 30. Okay. If there is no sign specified, then the default is positive. Just like I have mentioned below, 23, that means positive 23 and no sign is visible. Also in integer constant, you cannot have commas or blanks. And here are some examples of integer constants, like any positive or negative number without any fractional and decimal part. So guys, let us see the next constant now. Real constants are also known as floating point constants, and they are categorized into fractional and exponential form. So let us see them one by one. First, the fractional form. This form involves numbers with a decimal point to separate the integer part from the fractional part. Here are some rules. It should have at least one digit. There should be a decimal point like 23.5. It can be positive or negative. If there is no sign, then it is assumed to be positive. You cannot add commas or blanks in the real constant. Now let us see the exponential form of the real constants. This is used when the real constants are either too large or too small. That's why it uses small e or capital E to denote powers of 10. The constants are represented in two parts in exponential form. The part before e is called mantissa and the part after e is called an exponent. This scientific notation of small e or capital E is to denote powers of 10, making it easier to represent very large or very small numbers. So here are some rules for constructing real constants in the exponential form. The e should separate the mantissa and exponent. The mantissa can be positive or negative. Just like we saw before, if there is no sign, it will be assumed to be positive. There should be at least one digit in the exponent, which is positive by default. Here are some examples. In this we have used the scientific notation E, like 2.3E5, 7.5E3 and others. Now let us see the character constants. These are single characters enclosed within single quotes. Okay, for example, letter A enclosed in quotes, a number 9 enclosed in quotes. Okay. So here are some rules for constructing character constants. The maximum length of a character constant is one character. Like I just said, the letter A, the digit 9. It should be enclosed within left pointing inverted commas, which I just said single quotes. Any alphabet, digit or special character can be a character constant. So here are some examples. Letter A, digit 7, special character percentage. Okay. These are all character constants in C language. Now let us see an example to define constants. You can use the const keyword to define constants in C language. Let us see an example on VS Code. Here is our VS Code. We created a project, Amit project. So let us add a new file now. Right click, new file. I'll name it demo7.c. Okay, and now we will write our program. We have mentioned the header file, then the main function. Now I'll create a variable. Let's say int a is equal to 50. Then I'll create a float variable b is equal to 33.25. Okay, and a character. Let's say I'll mention C only, or I can also add P. Okay, now convert it into a constant. So I told you to use the const keyword. Just proceed. Okay, now let us print them using the printf. For number we use %d and print a. I told you for integer we use %d. For float, because this is a float, I'll use %f /n and b. Last printf. Okay, sorry, I just did a mistake. That's it. For character, %c and /n. Now we have added, and this is also I'll fix. Now this looks fine. Okay, we added %f and it is a float. This format specifier is used for printing the float value. So the result you can expect as 33.250000. To reduce it, let's say you want only two values after the decimal. So instead of %f, mention 0.2f. Okay, now after the decimal there will only be two places. Okay, and that's it. Return 0. Save. Now in the previous program we added to run the code in terminal, but I'll change it now. Go to file. Like we saw before, go to preferences, then settings. Run in terminal. Search and uncheck this for code runner. Close this. File save. Now I'll run it. Right click, run code. So it printed. Here it is showing int and float in a single line. So I just missed the /n here. /n is for new line. We saw before also. Now this looks fine. Now 50 will be on the first line and 33.25 on the second line. Right click, run code. Here it is. Okay, 50 on the first line, then your 33.25 and then P. I told you since we added .2 F, only two decimal places are visible. Guys, we saw what are constants in C language. We also saw the types and ran a program to create constants in C language. Thank you for watching the video. In this lesson, we will see what are comments in C language. With that, we will also see the types and examples. Let's see. Comments in C programming are used to explain the code and make it more readable. Remember, they are ignored by the compiler, which means they don't affect the execution of the program. Consider it like providing extra details about your program. So if you want to share your program with your colleague or team member, you should definitely write comments so that it's easier for anyone to understand. You can also write the purpose of the code, the author of the code, as well as the date on which it was written. With that, you can add a comment after each and every step so that it's easier to understand the code snippets. There are two types of comments in C, single line as well as multi-line. Let us understand them one by one. So as the name suggests, single line comments are only on a single line. Okay, and they are represented by double slash. So let us add comments to our program. So this is our VS Code, and this was our project. Let us create a new file. Right click, new file, demo8.c. So here I'll write a code quickly. First I have added the header file stdio.h and the main function. Now I'll create a variable int a is equal to 5. Okay, and let us add a comment to it. So I'll directly mention here. We need to use double slash for single line comments. Let's say creating a variable or declaring a variable. Okay. Then I'll display the variable. So I've mentioned the comment. So these two lines will get ignored by the compiler. These are comments to understand the code. I'll print it. Okay, that's it. Now go to file, click save. So we have added two comments using double slash. These are single line comments on a single line only. Okay, that's it guys. Right click, run code. Okay, wait, we forgot the format specifier. Fine, save, right click, run code, and here it is, value of a is equal to 5. So you can't see this and this because these are ignored by the compiler. So in this way guys, we can create single line comments. Guys, we saw how we can create single line comments in C. Now let us understand multi-line comments and create an example. So these can be extended over multiple lines. Let's say you want to write what is this program about. So you need to write multiple lines. You cannot use the double slash. For the next line, you need to use multi-line comments. Okay. So we use the slash here like this, a single slash with the asterisk for beginning as well as the end. Let us see an example. Okay, so this was our code. We added single line comments. Now here we will add double line. So I'll write like this, and you can see it automatically added the ending. And when I'll press enter, it will go to the next line also. So here you can mention a basic C program to create a variable and print it. Okay. And I can also write the author name. So like the single line comment, this will also get ignored by the compiler. So this is the multi-line comment. Okay. File, save. When I'll run it, you can understand more. Right click, run code. So here the same output is visible and you can't see the multi-line comment because it got ignored by the compiler. So for every code you can mention some multi-line comments like this. I did not added it for the other codes because I wanted to show it here. Okay. So guys, we saw what are single line as well as multi-line comments in C language. We understood it and also added to our program. Thank you for watching the video. In this lesson, we will understand what are operators in C language. We will also see the types of operators with examples. Let us start. C programming language includes a set of operators that you can use to perform different operations on data. These operations are performed on variables and values like a plus b. Let's say you have two variables with values a is equal to 5 and b is equal to 10. So you can add them using the operator. So plus here is an operator. Like this, we have different operators in C language: arithmetic assignment operator, relational operator, logical, unary, and conditional operators. So let us see them one by one with live running examples. Let us start. The first one is arithmetic operators. It is used for basic mathematical operations like addition, subtraction, division, and others. So in the table you can see the name of the operators with the operator and an example. We have the plus operator like a plus b to add, minus, that is subtraction, to subtract. We also have multiplication, division, modulus, and exponentiation. In the example we have shown, let's say we have two variables a and b. On the right in the example we have shown how these operators are used. Now let us see a live running example on VS Code to understand arithmetic operators. So here is our VS Code. We are having this project, Amit project, with all the C programs. Let us create a new file. Right click, new file. I'll name it demo9.c. So here we will work with arithmetic operators in C. Now I'll add the header file and main function. Okay, so first we will declare three variables and also initialize it. So let's say we have these three variables, int a, b, and c. A I'll assign 50, b let's say 100, and c 150. So now we will perform the addition, subtraction, and other operations. Okay, so I have mentioned the text arithmetic operators. Now I'll directly print the operators one by one. I'll first get the value of a and b is equal to, if you remember, for integers we use %d, and here I'll directly print a plus b. So we also added parentheses so that the output is a plus b. Now we are finding the addition. I'll take this line and copy, and I'll paste it so that I can work around other operators. Paste, paste, and that's it. Okay, I'll add semicolon first. So first we did plus, now we can do b minus a, let's say. Okay, here also I'll mention b minus a. So this is for subtraction. Next is division. So let's say I'll type c divided by a, and here also in the output. Next, multiplication, a into b, and here also, and the modulus, okay, c, okay, that's it. File, save, right click, run code. Okay, new line here. I think this is fine. Save, right click, run code. Okay, so here it is. We have printed the arithmetic operators. A plus b 150. Okay, here are the values. B minus a 50. C divided by a 3. A into b 5000. And for the modulus, it's not showing modulus. So I'll just add it like this and it will show now. File, save, right click, run code. Okay, here it is. Now it is showing C modulus B is equal to 50. So in this way, guys, we can work with the arithmetic operators. Now let us see the second type, assignment operator. It means assigning the value of the right operand to the left operand, like shown here in the table. Let's say you have two variables a and b, so a is equal to b is your assignment operator. Let us see an example again quickly. So this was our VS Code. I'll right click, click new file, and I'll write demo10.c. Comment. Okay, assignment operator in C. Now the header file and the main function. I'll take a variable int a, then int b. I'll also assign b is equal to 5, let's say. Assignment, okay, I'll use the assignment operator. So this will copy the value of b into a. When I'll print now, a will hold the same value as b. Okay, value of a, semicolon, copy and paste. Okay, value of b. That's it. Return 0. I should also add a new line. Save, right click, run code. Now here it is, value of a and b are same because we have used the assignment operator here. Okay. So guys, we saw what are assignment operators in C language. Now let us see the arithmetic assignment operator. It performs the same arithmetic operations like add, subtract, multiply, but it will also assign a value. That means arithmetic plus assignment. In the table you can easily see the operators plus is equal to, minus is equal to, and others. In the example, if a plus is equal to b, it means a is equal to a plus b. That is arithmetic assignment operator. A minus is equal to b is the same as a is equal to a minus b. Similarly goes for multiply, divide and modulus. So let us see an example on VS Code. So this was our VS Code. I'll right click, click new file, demo11.c. Arithmetic assignment operator in C. Now I'll add the header file and the main function. Here it is. Now let us take 5 variables and initialize them. Okay, so here are our 5 variables. Now let us start with arithmetic assignment. That means a plus is equal to 5, and I'll print it. Value of a is equal to percentage %d. I'll also add slash n, and here it is a. Okay. Now this is our add and assignment operator. I'll return 0 and I'll show you first this. Right click, run code. Here it is, value of 10. So what happened here? A was 5. We added 5 to this. 5 plus 5 is equal to 10 in the output using the arithmetic assignment operator. Similarly, I'll do for the rest. Okay. Let's copy, paste, again, that's it. Okay, now I'll change it. For B, okay, let's say minus. For C, multiplication, arithmetic assignment operator. D, D, okay, division. E, modulus, 9, okay, and I'll print it. Now I'll save and run. Right click, run. Here is the output. For A, it was 5 plus 5, 10. For B, B value was 10. 10 minus 5 is equal to 5. Similarly, C was 15. 15 into 5 is 75. C is equal to 75. For D, D was 20. 20 divided by 10 is equal to 2. And the last modulus, E was 30. When you will divide 30 by 9, the remainder would be 3. Here it is. So in this way, guys, we can work around the arithmetic assignment operators in C language. Now let us see relational operators. It is also called comparison operator, like comparing two values or expressions. They allow you to determine the relationship between two values and return a true or false result. In the table, you can see some examples like equal, not equal, greater than, less than operators, and the example on the right. Let's say we have two variables A and B. Let us see an example on VS Code. This is our VS Code. Let us create a new file. Right click, new file, demo 12. Relational operators in C. Now let us write the header file and the main function. I'll create three variables and initialize them. Now let us print. Now we will begin with the relational operators. We will also directly print value of, I told you, A is equal to B, okay, is equal to percentage %D and slash n also. Okay, this was for the first one. I'll save and print it. Later on I'll add more, but first return 0, okay. Save, right click, run code. Here output is 0 because A is not equal to B. 0 means false, okay. Now similarly I'll create for others. I'll copy and paste, copy, paste. You can also use Ctrl V to paste, so I'll do the same. Okay, now let us add for others. A is not equal to B. B is greater than C. And the same goes on, okay. So we have covered the operators equal, not equal, greater than, less than, greater than or equal to, and less than or equal to. Now I'll save and run. Right click, run code. Okay, now let us compare the output. Our A was 5, B was 10 and C was 15. Okay. First A is equal to B, no, false, so 0. A is not equal to B, true. These two are not equal, so true means 1. Is B greater than C? No, so false. Is C less than A? No, so false and 0. Is C greater than equal to B? Yes. 15 is greater than 10. So true. Is B less than C? Yes. 10 is less than 15. So 1. That means true. So in this way guys, we can work around the relational operators in C. Now guys, let us see the logical operators in C language. These operators combine conditional statements like shown in the table, like logical AND operator, logical OR operator, and logical NOT operator. It is true if both A and B are true. It is true if any of A or B is true. If A is not true, then the NOT operator. Let us understand with an example. This is our VS Code. I'll create a new file. Right click, new file, demo13.c. Okay, logical operators in C. I have added the header file also. Okay, now I'll add three variables. I've declared them. Now I'll initialize them. For our example, A is equal to 30, B is equal to 75, and C is equal to 0. Now let us print. Okay, so I'll use the if condition. We will also discuss the if decision making statement in the upcoming lessons. Let us give an introduction here. So if statement in C is a control flow statement that allows you to execute a block of code only if a specified condition is true. So here we will use if, and I'll mention A and B. Okay, and within that I'll mention true, and I'll also mention a basic text. Okay, I'll also add for the OR. And the last one, that is the NOT operator, which is useful when you want to execute a block of code based on the negation of a condition. So what I'll do here, I'll mention C and the AND operator B, and I'll negate it. If this is true, then the following will get printed. Okay, so I'll now explain what I did. Okay, so for the variables A, B and C, A is true, this is true, and this is false. 0 is false. Okay, so here when we will use the if condition, if this is true, the following will get printed. A and B are both true because they are true values here. So when we will compare both are true, therefore this will get printed. In the second one, we only need one condition to be true because it is OR. So A and B both are true, so it will get printed. Even if any one of this was true, it would have gone inside and printed. Now the last one, which is negation. Here it is showing that C and B. C is false. I'll mention C is false and B is true. But in AND, we want both to be true. That means this is false. This is false, okay? And outside we have negation. So false with negation means true. Therefore it will go inside and print this. Let us run it. I should mention return also. Okay, here it is, file, save, right click, run code. Here it is, I should add a new line. I should add new line also. Okay, now it's fine. Save, right click, run code. Okay. Here it is. All the three printed successfully because both conditions were true here. One of them was true here, and here it negated the false to true. In this way guys, we can work with the logical operators. Now let us see the unary operators in C language. It includes your pre and post increment and decrement operators. In the table, you can see in C language, we can use the plus operator twice for the increment operator and the subtract, that is minus, twice for decrement operators. Why it's written pre and post? When the operator is before the variable name, it is called pre, and if it is after the variable name, it is called post. Okay, so in the pre, first the a will increment, then return. In post, first the a will return, then it will increment. Obviously the variable name is visible first, so it will return first, then it will increment. In a similar way, it goes for the decrement, but obviously in decrement, plus will change to minus. That's it. So when we will see the example, the things will be more clear. Let us see. So here is our VS Code. Let us create a new file. Right click, new file, demo14.c. Let us mention the header file and the main function. Let us take a variable a and initialize it. Okay. Now first we will print unary increment. Okay, first I'll print a plus plus, the increment operator, percentage d, and here I'll mention a plus plus. Okay, I'll do the same. Copy and paste. Okay. Now the pre-increment, that is plus plus a, the opposite of above, and return 0. First we will understand this. File, save, right click, run code. Okay, I guess the file name, right click, rename. I added a space. Now it should be fine. Okay, right click, run code. Here it is. First add this also and the following also for the next part. Right click, run code. This looks fine. A plus plus and plus plus a. The value of a was 5. When it went here for a plus plus, what happened? It returned a directly, that is 5, and it got printed. But after returning, it incremented it. That means now the value was 6. And here when we went here, it added it again. That is 6 plus 1 is equal to 7. And it printed the same. So now a is having 7. So this was our pre and post increment. I'll do the same for decrement. I'll just copy this. Okay. Decrement. And the same concept will work, but here it is in negative. That's it. I'll click save, right click, run code. Now I hope you are able to guess what happened. So we were having 7 in a, it went here and it printed a directly, so 7. But after printing, it subtracted it, so 7 minus 1, 6. It went here again, decremented it, 6 minus 1, 5, and printed it. So in this way guys, we work around the unary operators. We saw the increment as well as the decrement operators, both pre and post. Now let us understand the conditional operators in C language. It evaluates Boolean expressions with 3 operands. So here in the example, you can see variable expression value 1 and value 2. So when the expression is true, it will print the value 1. If it is false, it will print the value 2. That's why it is called the ternary operator. That is the conditional operator based on conditions. It is used to create conditional expressions that can return one value if a condition is true and another value if it's false. Okay, the ternary here is the question mark and colon. Now let us see an example on VS Code. Let us create a new file. Right click, new file, demo 15.c. Okay. Add the comment and the header file with the main function. Now let us declare two variables, int a comma b. Let us assign 5 to a. We have initialized the variable a. Now let us start with the condition b is equal to a greater than 2 question mark. So here I'll add colon. So before the colon you need to print the true value. Let's say if it is 2, it will print 100, and if it is false, it will print 50. So I'm just giving a random example. I'll print the value of b. Okay. So a is greater than 2, right? A is 5, it's greater than 2. So it will print 100. Return 0. File, save, right click, run code. Here the value of b is equal to 100. It printed it because it is true. The true value is here, false is here. We can also do like this. B is equal to 10. I'll take another variable. Let's say int res. And here I'll print a and b. So the result will be here. So we just need to print res. And here I can mention the maximum value or the result only. Now I'll mention b here. So I've just molded the same program. Now if a is greater than b, it will print a. A is greater than b? No. So it will directly print b instead of a. So the output will be 10. And your output will get saved here. So 10 will get saved in res and you have printed 10. Let's see. Right click, run code. Result is 10. Okay, this is what I said. So we have also changed this example. So guys, we saw how to work with the conditional operator in C language. In this lesson, we saw what are operators in C language. We also saw 7 operators in C and ran all the examples related to these operators. Thank you for watching the video. In this lesson, we will understand what are decision-making statements in C language. With that, we will see the types as well as examples. Let us start. In C, decision-making statements control the flow of execution based on certain conditions. So it works similar to C++ and Java. So the same concept you'll also see in those languages. It is required when you want a set of instructions to be executed in a condition and another set of instructions in another condition. So when we will see the types and examples, then the topic will be more clear. Here are the types of decision-making statements: if else, if else, and switch statement. So let us start with the if statement. The if statement in C executes a block of code if a specified condition is true. Here is the syntax. The if statement is visible and within parentheses we can see condition true. So if the condition will be true, the statement will get executed. Under if statement, we can also execute multiple statements with a single condition as shown in the below syntax. The following is an example. We have also shown a flowchart. So your program begins, you have initialized a is equal to 10. After that, a condition is visible under if a is greater than 5. Yes, a is greater than 5, so the condition is yes. Therefore, a is greater than 5 will get printed. That's it. If the condition wasn't true, the program continues to the next statement after the if block. So now we will see an example on VS Code. Here is our VS Code. We created a project, Amit project. Okay. And let us now create a new file. Right click, new file, demo16.c. Okay. Now let us write the comment, header file and the main function. I'll initialize the same variable, int a is equal to 10. I have created a variable a and initialized with the value 10. Now let us write the if statement. If a is greater than 5, then the printf statement will get printed. The value is more than 5. Now let us run it. Go to file, save, right click and run code. Now here the output is visible. The value is more than 5 and it's visible. So we have seen the same example. Okay. So in this way you can implement if statement. Guys, now let us see the if else statement. We just saw the if statement. So in if else, if the condition is true, then a set of statements gets executed. If the condition is false, another set of statements gets executed. Here is the syntax. If the condition is true, the following statement will get executed. And if it is false, it will go to the else and the another statement will get executed. Okay. Let us see an example. Here we have also shown a flowchart. We have initialized a variable a with the value 10. Now a condition will be checked that is a greater than 5 or not. If it is 5, it will go to the left one, that is the yes condition, and a is greater than 5 will get printed. If it is not, then a is not greater than 5 will get printed. Similarly, it is shown in the example. If the condition is false, the code inside the else block is executed. So let us see two examples. First we will see if else statement, then we will see nested if else statements. Okay, so you can also nest these statements accordingly. So let us see the examples. Here is a VS Code. Let us create a new file. Right click, new file, demo17.c. I'll write the comment, header file as well as the main function. We have initialized the variable a with the value 10. Now let us use the if else statement. If a is greater than 5, it will print the first statement. The value is more than 5. Okay, and let's go to else. You don't need to write any condition here because it is by default. That means if a is greater than 5, then else means a is less than 5. So the value is less than 5. That's it. Okay, now we will print it and understand. file, save, right click, run code. Now what will get printed? The first condition only, the value is more than 5. Now what I'll do some changes. Set 2 here, let's say. Now what will happen? Save, right click, run code. The value is less than 5. Since it was 2, it went to the else condition and printed the value is less than 5. So in this way we can understand the if-else statement. Now let us see the nested if-else. Create a new file, right click, new file, demo18.c. Let us write the comments and header file with the main function. Let us take a variable a and initialize it with the value 5. Now the if statement. If I is greater than equal to 5, it's a. We will add a condition later. First let us set the else. Okay, under else it would be the value is less than 5, right? So the first one will be the value is greater than 5. But we will add a condition. If a is equal to 5, then within this print the value is equal to 5. And under else print the value is more than 5. Okay. Semicolon. Now let's see what will happen. Go to file, save, right click, run code. Now it printed the value is equal to 5. So this is nested if else. The value of a was 5. It first checked this. Is the value greater than equal to 5? Yes, it is equal to 5. So it will go inside this. And then it will check if a is equal to 5. Yes. Then it printed the value is equal to 5. Now let us do some changes. I'll mention, let's say 10. Save and run. Now what will happen? It will go here only because it's greater than equal to 5. But it will print this, not the following. Because the value of a is 10, not 5. Okay, it will print the value is more than 5. Let's see. Here it is. The value is more than 5. Okay. So in this way, guys, we can understand the nested if else. We implemented the same here. Let me set it to 5 only. Okay, now it's fine. So we saw both the examples. So in this way, we understood the if else as well as the nested if else concept. Let us see the next statement, if else statement. This statement is useful when the if statement has more than one condition. You can see the syntax also to understand. Previously we were working on if else, so if the condition is true, it will get executed. If it is false, it will go to the else statement. But in this we can add a statement within if else, that is else if, and we can add multiple else if statements. So let us see an example to understand. So here we have also shown a flowchart with an example. Here multiple conditions are evaluated in sequence. Our variable value is a is equal to 10. The first condition is checked, that is a greater than 15? No. Our value of a is 10, so it will go to the else if block, the second block. Is the value of a greater than 5? Yes. So it will print a is greater than 5 but less than or equal to 15. And we also have an else condition where a is 5 or less. So let's say the value of a is 2. So it will directly go to the else statement and print a is 5 or less. The same is visible in the flowchart also. In this, the code evaluates multiple conditions in sequence, executing the corresponding block when a condition is true, or executes the else block if all conditions are false. I just told that if the value of a is 2, every condition will be false. That is if as well as else if, and the else will get printed, that is a is 5 or less. So let us see an example. Here is our VS Code. Let us create a new file. Right click, new file, demo19.c. We will add the comment. So we added a header file as well as the main function. Now we will see an example to execute if else if else. First, I'll take a variable a and initialize it with the value 20. Now the condition, if a is greater than 100, then it will display the statement printf, the value is more than 100. Okay. Now another condition, else if a is greater than 75, so it will print the value is more than 75. Now another condition, a is greater than 50, the value is more than 50. And the last, so it will go to else. If none of the statements are true, it will go to the else and print the value is less than 50. That's it. Okay. Semicolon and return 0. File, save, right click, run code. Now it printed the value is less than 50. Why? Because one by one it will check. Currently a is 20. A is greater than 100? No. It will go here. A is greater than 75? No. A is greater than 50? No. So it will go to the else and print it is less than 50. Now what I'll do some changes. Let's say I'll set it to 70. Right click, run. Now what will get printed? I hope you guessed it correctly. The value is more than 50. What happened? It went here. First it checked, is it greater than 100? No. So it will go here. It is greater than 75? No. It is greater than 50? Yes, it is 70. So it will print the value is more than 50. So in this way guys, we can work around the if else statement. I'll again set it to 20 for our example. Okay. File and save. Now let us see what is a switch statement in C language. It is used for multi-way branching, allowing you to execute different blocks of code based on the value of an expression. It is a more readable alternative to multiple if else statements. So we just saw if else. If there are multiple statements like that, then a better choice is to use a switch statement. Okay, here let's say you want to give grades to the students on the basis of marks, so you can use switch statement. We have shown a syntax. The expression here is a Boolean expression and the values are constant. Here we have break statement also. So let us see an example to understand the concept. So as I said before, it is a better option to handle multiple conditions as compared to multiple if else statements. Okay. It is also a control statement. It will test a variable against a list of values and will execute the corresponding block of code. So let us see an example to understand the concept. Here is our VS Code. Let us create a new file. Right click, new file. I'll name it demo20.c. Okay, let us add a comment with the header file and the main function. Now we will create a program that uses a switch statement to print the name of a day based on the value of the variable day. Okay, so first I'll take a variable day. Let's say I'll initialize it to 5. After that I'll take the switch, and within this I'll include the variable day. Now we will add the cases, that is multiple conditions, beginning with case 1 colon and mention the printf. So if the value was 1, it would have gone inside and printed the day 1, that is Monday. Okay, and a break statement. So we will also see what is a break statement in the upcoming lessons. Here you can understand that it is used to exit the loop. Here, if it prints Monday, then the execution will break out of the switch statement and it will end. Similarly, for all other days of the week, I'll mention different cases. Case 2, okay. Tuesday, and then the break statement again. Now I'll add for the rest of the days quickly. Okay, now I have added for all other days: Wednesday, Thursday, Friday, Saturday and Sunday. What if the user enters something else? In that case, we also have a default case in switch statement. So if something else is entered, it will go to the default and print invalid day. Okay, now we will run it and we will see how to handle multiple conditions and execute different printf statements based on the value of the variable day. Save, right click, run. Friday. Okay, what happened here? Day was 5. It went here and it checked with the cases. Okay, 5 was here, so it went here and printed Friday. After that, it exited the switch statement. Let's say I'll mention 15 here. So what will happen? It will go here. There is no 15, so it will go to default and print invalid day. File, save, right click, run. It printed invalid day. Okay, we can remove this. Run. Okay, it will print invalid day. So guys, we saw how we can work with the switch statement to handle multiple conditions. In this lesson, we saw what are decision making statements. We saw if else, if else, if else, and the switch statement also. Thank you for watching the video. In this lesson, we will understand what are loops in C language. We will see the types with examples. Let us start. Loops are fundamental constructs in C that allow you to execute a block of code repeatedly. So if you want to repeat a part of the program, instead of repeating it again and again, use a loop. So repeat a part of the program until a condition is satisfied is what you can call a loop. Here are the types of loops in C language: while, do while and for loop. Let us understand them one by one with examples. The first one is while loop. The while loop executes a block of code as long as a specified condition is true. For example, marks of students with more than 75 in maths. Okay, that is if this condition is true, the statements will get executed. So here is the syntax of the while loop. You need to check a condition. If it is true, then multiple statements gets executed. Within that, you can also increment the loop counter. So the loop counter is like a plus plus, I plus plus. That is, I told in the operators lesson, I plus plus is equal to I plus 1, a plus plus is equal to a plus 1. Okay, so in this way, your variable will have a counter that will increment while the condition is still true. So when we will see the example, the things will be more clear. Here is an example with a flowchart. So let's say you created a variable I and initialized it to 0. Okay. Then the condition will be checked in the while loop. So let's say the condition is I less than 5. Since our value of I is 0, the condition is true. That is yes. Therefore, using the printf, we will print the current value of I, and after that the loop counter is visible, I plus plus. So I is equal to I plus 1. Okay. Then the value of I will increment. It was 0 initially. After the first printf, it will be 1. Now the loop will again check, is I less than 5? Yes, I is 1 right now. 1 is less than 5. It will go inside again and it will print 1. Then it will use I plus plus, that is value 2. Again it will go above in while and check, is 2 less than 5? Yes. So in this way it will go inside again and this will print until the value of I is less than 5. Let's say now the value of I is 5 after all the increments. It won't get executed because the condition is I less than 5. Now let us see an example on VS Code to understand it. Here is a VS Code. We created Amit project and added all our codes. Let us create a new file. Right click, new file, demo21.c. I'll add a comment as well as the header file and the main function. While loop in C. Okay, now let us run our code. Let's say the value of I is 0. We have initialized an integer variable I to 0. Now we will use the while and within that we will add the statement. Let's say the condition is I less than 5. Okay. And it will print the value of I also one by one. I is equal to %d. I hope you remember. We use %d as a format specifier for integer. And I'll add a /n also. So it will print the value of I and after that it will increment. So I hope you remember this operator. This means I is equal to I plus 1. Okay. Now when I'll run it, what will happen? First the value of I is 0. It will check, is 0 less than 5? Yes. So it will go inside here and it will print the value of I is equal to 0. After printing, it will increment it and the incremented value will go under I only because it is I plus plus. I is equal to I plus 1. So now the value of I is 1. It will again check, is I less than 5? Is 1 less than 5? Yes. So it will again print 1 and again increment it. Now the value of I will be 2 and it will check again, is 2 less than 5, and the process will repeat. Till when it will repeat? Till the value of I is less than 5. So right click and run code. Let's see the output. So I told you it will one by one print. First it printed I is equal to 0, then incremented, then 1, then incremented again 2, 3, 4. When it was 4 here, it incremented and the value is 5 now. It will go here again. Is 5 less than 5? No. So it won't go inside and won't print it. That's it. This is how looping works in C language. Okay. So guys, we saw the while loop that executes the statement if the condition is true. Now let us see the do while loop in C language. It is similar to while, but it has some differences also. The do while executes the statement first and then the condition is tested. Here is the syntax. Above you can see do instead of while. Remember while loop? So it will go inside and print the statement without even checking the condition. Okay. Then it will increment and then the condition will be checked. If the condition will be true, it will again print the statement and increment the loop, else it will exit. That means in do while, the statement is executed first and then the condition is tested. You can see the condition in the bottom instead of in the top if you'll compare it with the while loop. So let us see an example. Here is an example with the flowchart. So we initialized a variable, let's say I is equal to 0. After that comes your do while loop. There is no condition initially, it will print the value of I 0. After that it will increment and add the same I value after incrementing to I only, because I plus plus is equal to I is equal to I plus 1. I told it in the operators lesson. Now we have the value of I as 1 and the condition will be checked. Is I less than 5? Yes. It will again print I and again increment it till the value of I is less than 5. Okay, so let us see an example on VS Code. Let us create a new file, right click, new file, demo22.c. This is do while loop in C. I'll add the header file and the main function. Let us take a variable I and initialize it to 0. Now take the do while loop and I told you it will first execute the statement. So let us print the value of I. %d is a format specifier and print the value of I and then increment. And I told you this is equivalent to I is equal to I plus 1. And now the while loop. I is less than 5. Okay. And a semicolon. Let us print it. File, save. Now what will happen? Currently the value of I is 0. So first it will go inside here because there is no condition here, right? It will print the value of I is equal to 0. Then it will increment it and add it to I only. So now the value of I will be 1. Is 1 less than 5? Yes. So it will again repeat and print the value of I as 1. Then it will increment I to I is equal to I plus 1. That is, now the value of I will be 1 plus 1, 2. It will check is 2 less than 5. Yes. It will again go and print. Similarly, it will print. Right click, run code. Here it is. It printed the value of I 0 because it will directly print it without reaching here first. That's why it printed 0. And after that, by incrementing, it will go till 4. When the value of 5 will be here, then is 5 less than 5? No. So it won't go ahead. That's it. It will print the value of I like this. Now let us see the for loop in C language. The for loop is typically used when you know in advance how many times you want to execute a statement or a block of statements. Here is the syntax. Under for, you need to initialize the loop. Then you need to test the loop with the condition, and after that you need to increment the loop. When the condition will get satisfied, the statement inside it will get executed. Let us see an example. Here is an example with a flowchart. So in the for, first we initialize the variable I with 0. Then a condition is set for the variable for testing. And if this gets satisfied, the statement will get implemented. The same is implemented in the flowchart. We have initialized the value of I as 0. Then the condition is checked that is I less than 5. If it is yes, then the body will get executed and the value of I will print. Also, I will get increment with I++. Now let us see an example on VS Code. Here is our VS Code. Let us create a new file. Right click, new file, demo23.c. Let us write a comment. Now header file with the main function. We will take a variable, let's say I. Now use for loop. Initialize the value of I is equal to 0. We could have also written int I here, okay, and removed the above one. But let us keep it like this. I is equal to 0. Then what will happen? Semicolon, condition I is less than 5. Then the increment, okay. And if this satisfies, it will print the value of I. I is equal to %d is a format specifier, and let's add /n also because it will repeatedly print and the value of I. Let us return, save. Now the value of I is 0. Is it less than 5? Yes, so it will print it and it will go on. Right click, run. Now what happened? It printed the value of I here 0. Then again it went here and tested the value of I and printed it. This will happen till the value of I is 4. When the value of I will be 5, it will get checked here. 5 is less than 5. No, so it won't go inside this. It won't go here, and that will be the end of the program. So in this way, I iterated 5 times with for loop. So guys, we saw what is a for loop in C with examples. In this lesson, we saw what are loops in C language, what are the types of loops with examples. Thank you for watching the video. In this lesson, we will understand what are break and continue statements in C language. With that, we will also see some examples. Let us start. Break and continue statements are loop control statements in C language. If you want to repeatedly execute a block of code, use the loop control statements like break and continue. These are also called control flow statements that will allow you to alter the execution flow within loops and switch statements. We saw the switch statement in the previous lessons. Now let us see how both break and continue works. We will also see some live running examples. Let us start with the break statement. The break statement is used to jump out of a loop. That is, if you want to exit the nearest enclosing loop or switch statement, immediately use the break statement. So break statement basically terminates the loop. Here is the syntax of the break statement. Let us see an example. Here is an example with the flowchart. We have shown a for loop. We already saw some examples of for loop in the previous lessons. So if you want to immediately terminate the loop, use the break statement. Like we have added if statement inside the for, when the value of I will be 5, it will immediately terminate the loop using the break statement. Also the same is visible in the flowchart. Initially the value of I is 0. The condition was true, therefore it went to the yes, that means the true section. That is to execute the loop body. It printed I. The loop goes on till 5. When it reached 5, using if statement, the condition was checked, and when I was 5, immediately using break, it terminated the loop. The same is visible in the flowchart. Now let us see a live running example on VS Code to understand the break statement. Here is our VS Code. We added all our project inside Amit project folder. Let us create a new file. Right click, new file, demo24.c. We will add a comment and now the header file with the main function. Let us take a variable I and initialize it with the value 5. Now we will show an example using a while loop. Let us take a while loop. We already understood the while loop in the previous lessons. So let's say the condition is less than 10. What will happen if the value of I is less than 10? It will print the value of I, new line, and I will be printed. After that the I will be incremented. When the value of I will be greater than 7, what will happen? The break statement is used to immediately terminate the loop. Okay. Now that's it. Add a return. I'll run it. Right click, run code. Now what happened here? It displayed I is equal to 5, 6 and 7. How? Initially the value of I was 5. So the condition was checked. Is 5 less than 10? Yes. So it will print the value of I as 5. Like here. Then it incremented the value of I. So the value of I is 6. It will check here. Is 6 greater than 7? So it won't go inside the if. It will repeat. The value of I was 6 here. 6 is less than 10. Yes. So it will print 6. Here it is 6. After that increment the value of 6 to 7 like from here. I told before this is I is equal to I plus 1. That means the value of I is 7 now. If 7 is greater than 7, then use the break statement. No, it's not right. So it won't go here. It will immediately reach here. 7 is less than 10. Yes. It will print 7. That means here. And increment it to 8. Now is 8 greater than 7? Yes. So it will go to break. And it will immediately terminate the loop. That's it. And the final output is I is equal to 5, 6 and 7. In this way guys, we can use the break statement in C. Now let us understand the continue statement in C language. The continue statement skips the remaining code in the current iteration and proceeds to the next iteration of the loop. That means if you want to pass the control to the next iteration, use the continue statement. Unlike the break statement, the break statement will completely terminate the loop. Okay. Here is the syntax of the continue statement. Write continue, then a semicolon, just like break statement. Here is an example of continue statement with the flowchart. So we have shown a for loop and within that an if statement. Initially the value of I is 0. Keep on comparing it to the left flowchart also. When the value of I modulus 2 is equal to 0, then the continue statement will apply. That means when I is an even number, the continue statement is executed, causing the loop to skip the remaining statements in the current iteration and proceed directly to the next iteration. In the flowchart it's visible. Initially the value of I is 0. Condition is being checked, I is less than 10, yes. It will go to the yes section, that means the true section as per the flowchart. After that it will execute the loop body. That is, the loop body here is I modulus 2 is equal to 0. So this is the modulo operator which returns the remainder of the division of one number by another. So when the value of I is 1, 1 mod 2 is equal to 1, not 0. Okay. Then it won't continue the statement because the if condition will fail. 1 mod 2 is not equal to 0. Therefore it will print the value of I. That means the value 1. After that the loop will again increment. 2 mod 2 is equal to 0. It will execute the statement, that is the if statement. So continue statement will get applied and the value of I2 won't get printed. It will again increment and go to 3 till the value of I is less than 10. So let us see an example on VS Code. Here is our VS Code. Let us create a new file. Right click, new file, demo25.c. I'll add a comment, continue statement. In C, now let us write the header file and the main function. We will take an integer variable. Int I is equal to 100. Now let us take do while and an if statement. If I is equal to 110, then I is equal to I plus 1, that is I plus plus, and after that apply continue. Outside the if, print the value of I and increment I again. Here is the while. Okay, let us add a condition while I is less than 115, semicolon, return 0, file, save, right click, run code. Look what it printed. It printed 100 to 114. Within that it skipped 110. Let's see why. Because the condition is 110. Initially the value of I was 100. It went to the do while loop without checking any condition. It will go here. If I is equal to 110, no, it's not. So it won't implement this. It will directly print the value of I, which is 100. Okay, it printed. Then it incremented I. Now I is 101. It will check, is 101 less than 115? Yes. So it will completely implement. Now I was 101. So this won't implement and it will print 101 here. And after that it will increment I 102. This will go on until the value will reach 109. Okay, here we will have 109 and it will increment to 110. 110 is less than 115. Yes. So it will check if I is equal to 110. Yes, it is. So it will increment it. That's it. So the value of I will be 111 and it will continue. 110 won't get printed. Continue means it will go again here. Is 111 equal to 110? No. So it will directly go here and print 111. That's why it skipped 110. And this procedure will go on till 114. It will print here. It will increment after that. 114 plus 1 is equal to 115. Therefore it will check 115 is less than 115. No. So the execution will end. Therefore from 100 to 114 we printed, except the condition 110 is missing because here is the condition. So in this way, guys, we can work with the continue statement in C language. Guys, we saw what are loop control statements in C language. We understood the break and continue statements with examples. Thank you for watching the video. In this lesson, we will understand what are arrays in C language. With that, we will also see how to declare, initialize, and work with arrays with examples. Let us start. Arrays in C are used to store multiple values of the same type in a single variable, allowing you to organize and manage data more effectively. It is a data structure to group elements. So in this lesson, we will learn how to work with arrays in C language. Let us understand the concept of arrays. Consider you have a class of 20 students and you want to arrange the marks of all the 20 students. So you can use any of the two methods. This will help us in knowing the importance of arrays. Beginning with the first method, in programming you can declare 20 different variables for each student's marks. Okay, like shown here, int marks 1, marks 2, marks 3 and goes on till marks 20. But this isn't looking like a proper solution, right? It would be more chaotic, and 20 variables in a code when we can do it in a better way is what we call an optimal solution in programming. So this was the first method. Now let us see a better solution, that is the second method. Just declare a single array variable and store the 20 different integer marks values. Okay, like shown here. So this will be a one-dimensional array. So the 20 different values of marks will get stored in contiguous memory locations. That means the elements of an array are placed in adjacent memory cells, which makes it easy to access each element using its index. Here we have mentioned the data type int, then the marks variable, and using the array subscript operator, we can declare an array. Within this, can you see 20? It is used to specify the number of elements the array can hold. So here we have declared an array of 20 integers. That means the marks of 20 students. As you can see here, the first element always begins with the 0th index. Index 0 is the first element, index 1 is the second element, and it goes on. So obviously the second method is better. Using array fixes the problem we saw in the first method. So method 2 is better. We saw two methods and definitely the second method is better. Because in this you don't need to declare different variables for all the 20 marks values. Above we have used the square brackets. Index 0 was for the first element and similarly it goes on. Since the first element was index 0, the last element will be 19. That means the 20th marks will be at index 19. So these terms will be valuable for you to understand the concept of arrays. Let us move further and now declare and initialize arrays. We have learned how to declare and initialize variables. You can relate the same concept. To declare arrays, you need to use the following syntax. First, write the data type like we mentioned int. Then the name of the array, we have mentioned marks. And within the square brackets, you need to mention the size of the array. Here, 3 in the square brackets would mean declaring an array with 3 elements. Now the variable array marks holds 3 elements. So this is how you can declare arrays. Now let us see how to initialize arrays. You can add the array values in a single line. Like we saw the previous example for int marks with 3 elements. To initialize it, you can add it in a single line as shown here. Here we have initialized the marks array with three values 90, 75, 88 under braces. Element 1 is at index 0, I told you before, and the last element is always size minus 1. Like for the marks of 20 students, the last element was at index 19th. That means size minus 1. Similarly here, so as I told, index 0 for first element, that means mark 0 is 90 here, and the last element is size minus 1. That means in this case we have 3 students, therefore marks 2 would be the value 88. That means the last index is size minus 1. The last element is located at size minus 1. So we saw how to initialize arrays. We will now see our first example to create arrays in C language. This will be a one dimensional array. Let's see. Here is our VS Code. We created Amit project. Okay, let us create a new file here. Right click, new file, demo26.c. Let us add the comments. I'll add the header file and then the main function. Now let us create a marks array with 3 elements. I already told you. We will take the same example we just saw. So here our array name is marks, and now we will add 3 elements under braces 90, 75 and 88 semicolon. Now let us also declare 2 variables int I and j. We will display the elements. We will use for loop I is equal to 0. We already declared I, so I am not writing int here. Okay. We already discussed for loop in the previous lectures, so I'll now set the condition to test and I++ for increment. Print it. So instead of displaying them individually, we just use the loop. Let's say you are having 10 or 20 marks, then imagine the purpose of loops also and arrays to ease your work and to reduce the line of code. Marks. So here what I'll do, I'll mention %d here. That means format specifier for integers is equal to %d. So this is the best way to run a program related to arrays to understand it. When I'll run, you'll understand it more. Marks, and in square bracket mention I. Okay. When I will be 0, it is less than 3. It will print marks 0 is equal to the value of the marks, that means 90. Let us run it. First I'll return. We have added 2 format specifiers here. That means we are printing 2 values. Here we will print the I value. So mention comma I and then comma marks I. This will be the element, individual elements. That is, when the value of I will be 0, it will be marks 0. When it will increment to 1, it will be marks 1, and similarly it will print it. Save, right click, run code. Now we printed. Okay, when the value of I was 0, marks 0 is equal to the following, marks 0, that means 90. When I increment it, now the value of I is 1. 1 is less than 3, it will go inside the loop and print marks 1 is equal to marks 1. That means 75. Similarly for the last one. In this way you can create and initialize arrays. Now let's say you want to individually print them. Printf. Okay. Marks of student 2. Let's say you want to print the marks of student 2. Okay, is equal to, I'll mention %d again, and here marks 1. Why I added 1? Because index 0 is your first element, index 1 is your second element. Here I mentioned index 1 for the second student, that means 75. Or I can mention marks of the second student. Similarly, I can copy this and paste it here to print the marks of the last student, that is 2. It's always -1. Now I should also show you the first one so that there is no confusion. I'm just showing it to explain the concept of the first student. Okay, I hope you can guess it now. It's index 0. So it will now individually print them. File, save, right click, run code. Now first we printed this. Okay, here then we printed them individually. Here it is, student 190, student 190, student 275, student 388, and here it is. So in this way you also learned how to access array elements in C language. So this was one-dimensional arrays in C language. Okay. Now let us see what are two-dimensional arrays in C language. We just saw what is a one-dimensional array and we also ran a program. Now two-dimensional arrays are used to represent a matrix or a table of data where each element is accessed using rows and columns. Consider them as arrays of arrays. First you need to write the data type, let's say int, then the name of the array similar to one-dimensional array. But after that you need to use two square brackets, one for the number of rows and the second one for the number of columns. For example, your array name is marks. For two-dimensional arrays, you need to mention two square brackets, like here we have shown 3 rows and 3 columns for marks array. Okay. Now when you will represent two-dimensional arrays, let's say here for 3 rows and 3 columns, it will be accessible like this. For first row and first column, your marks is at the 0th index, that is marks 0, 0. Then for first row and second column, since this is the first row, its index would be 0, so marks 0. And since the column is second, its index would be 1. Therefore marks 0, 1 for first row and second column. Similarly for the entire matrix. Consider two-dimensional arrays as a matrix like arrays of arrays. That's why we have two square brackets in it. Now let us see an example to create a two-dimensional array in C language. We will create an array that will be having 3 rows and 4 columns. We will also initialize that array and also print it using for loops. After that we will also access and modify any of the elements in it so that you can understand how to work with two-dimensional arrays. Let us start. So here is our VS Code. Let us create a new file. Right click, new file, demo 27.c. Let us add the comment. Two-dimensional arrays in C. Now I'll add the header file and the main function. Let us create an integer array, a two-dimensional array. So we can name it marks, or let's say I'll name it matrix, because a 2D array is a matrix only, so it would be easier for us to understand. I'll take 3 rows and 4 columns. The first square bracket will have the number of rows and the second will have the number of columns. Okay, now let us initialize it. So this is for the first row, comma, this is for the second row, and this is for the third row. So within this we will add our elements, and this is the syntax, add a semicolon here. Okay, now add your elements. So this is your first row. We have 3 rows, right? and 4 columns. So add the values for 4 columns. Let's say I'll add some elements. So 1, 2, 3, 4 here. I'll add 5, 6, 7, 8 and 9, 10, 11, 12. Now let us print. I'll use a for loop. I is less than 3. So I have added I is less than 3 because the number of rows were 3. So this is how we print a matrix in C language. Now what I'll do, I'll add a nested for loop. That is a loop statement inside another loop statement. Loop inside loops. Now int j, I'll take another variable. I hope you can guess it correctly now. It will be less than the number of columns. That is 4. So this is how we will print a matrix. J++. Okay. Within this, use printf and print your matrix. Let's say I'll print it like this, %d, %d. I hope you remember this format specifier is equal to %d. This will be the value. This is the row, this is the column, and this is the value. So after the comma, what you will write? I, j, I for row, j for column. I missed this. I for rows, j for columns, and the last one would be the array value. That means matrix ij. Semicolon. That's it. I'll first print this and later on access it. Let's say I'll print this. Go to file, save, right click, run code. Here it printed it, but we missed the /n. Okay, I have added this. It should be like this. Now it's fine. File, save, right click, run code. No, this is incorrect. We did a flaw. This, we forgot to initialize this. This looks fine. Now from I to j, right click, run code. Here it is. We printed all the values. Okay. If you added marks of students, it would be student 1 marks, student 2, student 3, student 12. So I also explained you the structure in the PPT. It was like this only. The first element marks 0, 0, 0 row, 0 column. 0 row first column was second. Let me compare it. It would be easier for you to understand. 0 row, 0 column was 1. 0 row first column was 2. 0 row in the sense first row. So this is an index like 0th index for the first element. Similarly, you can compare them with this. The first 4 was for this row. The next was for this. You can compare, and the last 4 was for the last row. In this way, you can print a two-dimensional array. Now let us access. I'll access a specific value, original matrix 2, 3, second row, third column. Okay, is equal to %d and a /n. So here what you will mention, obviously which value you want for matrix 2, 3. Okay. After that, what we will do, we will just update it. Matrix 2, 3 was, let's say, 50, and then we will print it again. Copy, paste. Okay. Updated 2, 3. Okay. This looks fine. File, save, right click, run code. Now it printed first, then it printed a specific value, which was matrix 2, 3. matrix 2 3 was 12. That means third row fourth column. That means third row fourth column, that is this. We updated it with 50 here, okay, and we printed it. So in this way you can create a two-dimensional array and also update it, access the elements and also update it. So guys, we worked around the two-dimensional arrays. In this lesson we saw what are arrays in C language. We also saw what are one-dimensional and two-dimensional arrays with examples. Thank you for watching the video. In this lesson we will understand what are strings in C language. We will also see how to declare and initialize strings in C language. With that we will also see an example. Let's start. Strings in C are arrays of characters that are terminated by a null character. They are used to store and manipulate text. Since C does not have a dedicated string data type, strings are typically represented as arrays of characters. Here let's say you have a string Lionel, Lionel, and you need to declare and initialize the same string in C. For that you can use an array of characters like this. Use the char data type, then the name of the array like we saw in the arrays lesson. So here we have given celeb, and after that you can mention the string. So what we have done here, we have initialized a string at the time of declaration. So here we haven't added the null character since the compiler adds it on its own. Also we haven't added the size because it is optional. It is automatically determined by the length of the string plus 1 for the null terminator. Okay, so this is how we can declare and initialize a string in C. Now let us see an example to create a string in C language. Here is our VS Code. We added all the projects in Amit project folder. Let us create a new file. Right click, new file, demo28.c. Now let us add a comment. I'll add the header file also with the main function. Now let us create a string. I'll declare and initialize in a single line like we saw before. Char celeb, then the string. Now let us print it. Since it is a string, we will add the %s format specifier and then the name. Here it's visible. Okay, that's it. This will print your string, that is array of characters. Go to file, save, right click, run. Here it is, we have printed our first string. Okay, like this. So in this way we can create a string in C language. So you can also declare and initialize the same string with the null character and size in square brackets like shown here with 7 as the size as well as each and every character with the null also. Let us see another example. So here we are writing the name of a website. Okay, the declaration and initialization of the above string can also be done like this. Here we have taken the array name as website. We have added array of characters and in the end the null character is also added. Here we haven't added the size because it is optional. So this is also how you can create a string in C language. So let us see another example. In this we will print the name of the website and we have represented each and every character. In the end, can you see the null character? And as I told before, in arrays, the index begins with 0. So that's why the word S of the website is at the 0th index. Okay, in this way, the flow of indexes and characters go on. Let us see the example. We will create a new file. Right click, new file, demo29.c. Let us add a comment. Okay, so here we are creating a string in C language with an alternative way, different from what we saw before. I'll add a header file and the main function first. Let's say our array name is website and I'll print the name of the website. Okay, first like this. Okay, the last character is a null character. So first I'll add that. Now one by one, I'll add the characters. Okay, here it is. We have added the characters one by one. Okay, and the last one is the null character. Now let us printf. Format specifier S for a string and the name. Return. That's it. Let us save and I'll print it. Right click, run. Okay, here it is, learning website for free tutorials and the name Studiopedia. We saw an alternative way to create a string in C language. So guys, we saw what are strings in C language, how to create a string. We saw how to declare and initialize a string. With that, we ran two programs to learn how to create strings. Thank you for watching the video. In this lesson, we will understand what are functions in C language. With that, we will learn to declare and define functions in C with examples. Let us start. Functions in C are blocks of code that perform a specific task and can be called from other parts of your program. They help in organizing code, making it more readable, reusable and manageable. So if you want to do a task again and again, just create a function and call it. That's it. So in this lesson, first we will create and call a function. Then we will see an alternative way to create a function by separating the function definition and declaration. After that, we will see the concept of parameters. We will create a function with a parameter and then with multiple parameters. Let us start. Let us begin with creating and calling a function in C language. This step tells the compiler about the function's name. So here we are declaring a function. Okay, with the return type to begin with, then the function name. You can add any name to your function. We have added the name demo function. Okay. In the parentheses, you need to add the parameters. We will see that later. So after creating a function, you need to call it. To call it, you just need to write the name of the function and then the parentheses. That's it. Also here you can see void is visible. So the void return type is used to indicate that a function does not return a value. Okay. Let us see an example to understand the concept. Here is our VS Code. We created this folder for all our examples. Let us create a new file. Right click, new file, demo30.c. I'll add a comment. Let us now add the header file. So we added a header file. We will now create a function. So the return type was void here. That means the function does not return a value. Then the name of the function, here we will add demo function. You can add any name. Parenthesis, we are not adding any parameters since this is a basic example. Now write anything here, a demo text. Let's say I'll type, this is a demo function. Okay. Then the main function. Within this, you can just call the demo function like this. Okay. This is the basic example. This is function call. And this was our demo function. That's it. After that, you can return 0, write return 0 here. That's it. So we created a basic function. We missed the semicolon. File, save, right click, run code. This is a demo function printed. So what we did in this code, we defined and called a function. Okay, so this was function declaration and definition. The function name is demo function. The return type is void. That indicates it doesn't return a value. This is the body of the function that is having a single printf statement that prints a message to the console. The following is the main function, as you know, and this just calls the function. The demo function is called within the main function, which causes the message, this is a demo function, to be printed. So this call will go here and print the body of the demo function. That is the output. This is the demo function. So in this way, we can create a basic C program. We can create a basic function in C language. Now let us see the second example. In the previous example, we saw how to create and call a function. We added the function declaration and definition. So here we will see an alternative way where you can separate both the declaration and definition. Let's see the example. Here I'll create a new file. Right click, new file, demo31.c. Okay, so I'll take the same example. Copy, paste. Okay. I can take it to the next line, and for that I'll use a multi-line comment. Okay. Now let us separate both of them. How we will do that? First I'll define the function. By writing demo function. So we have defined it. Now we will take this, cut, and we will add it after the main function. So we have separated the declaration with the definition. Okay, this is function definition, this is calling the function, and this is your function definition. Okay, so this was function declaration, this was function call, and the following is your function definition. That's it. We have changed the program. Now I'll run it, right click, run. Here is the output, the same output. This is the demo function. Okay, this printed. In the main function, function call was there. This went here and printed it. Okay, So this is different from what we did here. We did that in a single line, and here we separated the declaration as well as the definition. Okay. So this is how we can create functions in C language using two ways. Now let us see how we can add a parameter to a function. Now you would be wondering, what is a parameter? So function parameters in C are variables that are used to pass information into functions. They allow you to give input to a function so it can perform tasks based on those inputs. When you declare a function, you specify its parameters within the parentheses like shown here. Here our parameter is rank and it is represented by a data type and a variable name. So the data type is integer and the variable name is rank. If you want to call this, you need to set the value. So you can directly mention the rank you want to pass, that is the information you want to pass. So here we are calling a function with a parameter. The value for the rank we have set as 5. We have passed the rank with the value while calling above. Now let us run an example. We will create a new file, right click, new file, demo32.c. Add a comment, function parameters in C. Okay, I'll add the header file. Okay, let us create a function. Let's say I'll add the name details function, int rank. So this is our parameter, and I'll print the rank. It's integer, so the format specifier is %d rank. Okay. Then the main function for function calling, and while calling I'll pass the rank. Okay, let's say 5. Okay, and the return. So what we did here, function declaration and definition. We have passed the rank with the value 5 while calling. So when we'll call here, it will go here and it will print the value of rank as 5. Let's run. Go to file, save, right click, run. Here it is, rank 5 printed. Okay, from here, because we called. So we defined a function with a parameter and call it in the main function. We have passed an argument to the function when calling it, that is here. So we have defined a function with a parameter and passed an argument to the function when calling it. In this way you can create a function parameter in C. Now let us see the last example to create a function with multiple parameters. So we just saw how to add a single parameter. To add multiple parameters, you need to set multiple parameters separated by comma. Like shown here with the demo function, we have mentioned 3 parameters here. One is an array of characters player, that is a string, then the rank, that is an integer, and then the points, that is an integer. Now to call a function with multiple parameters, just pass each and every value. The first one was a string, array of characters, that's why I have passed my name Amit, then the rank, and then the points as integers. So we have passed the following parameters, multiple parameters while calling above, that is player, rank, and points. Now let us see an example of a function with multiple parameters in C. Let us create a new file, right click, new file, demo33.c. So I'll mention function with multiple parameters in C. I'll mention the header file first. Okay, then what I'll do, I'll take this code and change it, right click, copy, paste. So previously we were having only a single parameter. Let us add more parameters. So here only I'll add int points, and before that I'll add the array of characters, that is player, and the square brackets. Now we have three parameters. Let us print them. I'll right click, copy and paste them twice. Okay, first was rank, so here I'll change it to player. Player was a string, that is array of characters, that is %s format specifier. Player name, rank and points. Integer, so format specifier %d, and here points. That's it. Now when you will call, okay, so what will happen? It is showing an error. Why? Too few arguments. That I told you, this is an argument. Too few arguments. Why? Because we have three parameters here. So we will add the names. Let's say first I'll add Amit. Okay, rank is okay, rank 1 now and 100. Okay, file, save, right click, run code. Now it will print. Okay, I should have added the %n. Okay, here it is. I've added now. Okay, file, save, right click, run code. Now we have added the player name, rank and points are visible because we called it. We can also change it, copy. So we are calling it again with a different value. Okay, and it will print. Go to file, save. In this case, okay, right click, run code. We printed it. Okay, we should have added this here. Now this will work. %n, right click, run. Now you have two values. Here it is, player name and the second player with rank and points. So in this way, we can work with multiple parameters in a function in C. So guys, we saw what is a function in C language. We saw how to define, declare and create functions. We also got to know about function calling. With that, we saw 4 examples to create a function and then to work with parameters in a function. Thank you for watching the video. In this lesson, we will understand what is call by value in C language. We will also see an example. Let us start. In C, when you pass arguments to a function, the default method of passing these arguments is call by value. This means the copy of the actual argument's value is passed to the function. Any changes made to the parameter within the function do not affect the optional argument. This ensures data protection as the original data remains unchanged. Let us see an example on VS Code to implement call by value. Here is our VS Code. We created a new folder Amit project and added all the programs. Let us create a new file. Right click, new file, demo34.c. Let us add a comment. Now we will add the header file. Let us create a function. Within that, add a parameter, integer variable x. In the function body, I'll give a value 10 to the variable x. Here is the main function. I'll create an integer variable a and assign 5 to it. Now I'll call change value and pass a. Okay. And then I'll print the value of a. Since it's an integer, %d is the modifier. And here it is. Okay. return 0. We missed the semicolon. So what will happen when this will be called? The output will be 5, and this will not affect the actual parameter. The actual values you pass to a function when you call it is called actual parameters. Okay, now I'll just copy this and paste before calling. Let me mention this. Save, right click, run. Okay, I'll just mention the /n. Here you can see before and after the values are 5 only. Okay, and when I'll copy and paste here within the function, okay, right click, run. Now you can see the value inside the function would be 10. I missed the semicolon. Right click, run. Look, the value inside the function is 10 only, but here it is 5. In call by value, a copy of the actual parameter's value is passed to the function. That is, this value we are passing is a copy. Okay. Changes made to the parameter inside the function do not affect the original value outside the function. Okay. That's why the output was the following. Okay. It remained the same later on after calling. Also, the variable a is initialized to 5. The original variable a remains unchanged outside the function, demonstrating that the function only worked with a copy of the value. Using call by values ensures that the original data remains unchanged, making it a safe way to pass data to functions for read-only operations. This is what we saw. Okay, the value of a was 5. Here a got printed, then the function was called. Here the value was 10, therefore 10 got printed. After calling, when you will print the value of a, it will display the same 5 only. That means the value remains unchanged. Here it is. This is what we call by value in C language. So guys, we saw what is call by value. We also saw an example. We saw that when you call a function, copies of the arguments are made and passed to the function. Thank you for watching the video. In this lesson, we will learn what is call by reference in C language. We will also see an example. Let's start. In call by reference, the address of the actual parameter is passed to the function. That is, the actual memory address is passed rather than a copy of the argument. This allows the function to modify the original variable directly. C does not natively support call by reference, but it can be simulated using pointers. For that, pass the address of the variable. To pass the address, use the address of operator. Here actual parameters are the values or variables passed to the function when it is called, and formal parameters are the variables that receive the values of the actual parameters. So we will also see this in the example. Let's see. Here is our VS Code. We created a folder for all our codes. Let us create a new file. Right click, new file, demo35.c. we will add call by reference in C. Let us add the header file. Let us take the same code for call by value. Here we added a function. Okay, we added a function with a parameter, then we added a value here and called the function. Okay, we printed the value before as well as after to check that whether the value will get changed or not. But whenever we call, the copy goes here. Okay, and after reaching here, it printed the value of x10, and when it returned, the value was similar to before calling, that is 5. A is equal to 5. So it printed 5, 10 and 5. File save, right click, run code. I am just showing call by value here 5, 10, 5. Okay, now let us change it to call by reference. We will use the address of operator. First, I'll set this and the following also. Here we will set the address of operator. The function is called with the address of A. Okay. Here the output will be 10 since the original value changed. The function change value takes a pointer to integer, that is int star x. Here the value of A is 5. When we will print it, 5 will get printed. Now the address, you can see the AND, that is the address of operator. The address of the actual parameter is passed to the function. Changes made to the parameter inside the function do affect the original value. So now the value is 10 here. It is changed. I'll change it to this change will affect the actual parameter. Then it printed 10. When it will return, now the value is 10. Here it is 10 because the original value changed. Now when we will print it, the output will be 10. So the output should be first 5, then 10 and then 10. Let's run. Right click, run. Here it is 5, 10, but we missed the middle one. Let me set it to star 10. File, save, right click, run code. Here it is, we printed it. Okay, so it is different from what we saw before, call by reference. Here the value of A was 5, we printed 5. Okay, then the address of A is sent here. After reaching, the value is changed and this change will affect the actual parameter. So 10 printed here. When it will return, the value is 10 now, not 5. When we will print, the value will be 10. So the output is 5, 10, 10. Okay. So in call by reference, the address of the actual parameter is passed to the function, and this is what we did. We passed it. Changes made to the parameter inside the function affected the actual parameter, and we saw the same. So guys, we saw what is call by reference in C language. We also saw an example. Here we have passed the address of A to the function using the address of operator, that is AND. Thank you for watching the video. In this lesson, we will understand what is recursion in C language. We will also see an example. Let us start. Recursion in C is a programming technique where a function calls itself directly or indirectly to solve a problem. Recursion can simplify your code for problems that include recursive structure like tree traversal, factorial calculation, Fibonacci sequence and others. Recursion functions are more readable. It makes your code efficient and reduces the line of code. Here is an example displaying factorial. We have shown the recursive calls. Initially, let's say you are trying to find 7 factorial. So when your function, let's say your function name is calc, in the first call, the value 7 will be sent. In the second call, the value 6 will be sent with the previous 7. In the next call, the value 5 with the previous 6 and 7. In this way, it will calculate your recursion. That is 7 factorial in this case. Let us see an example to understand the recursion concept. Here is our VS Code. We created the following folder for all our C files. Let us create a new file. Right click, new file, demo36.c. Add the comments. Here is the main function. Let us create a function. We can add the name calc like we saw before, but let's say I'll change it to factorial function. Okay. We will pass an integer variable n, and within that, if n is greater than equal to 1, okay, if n is greater than equal to 1, we will return. Else, if it is less than 1, it will return 1 for factorial 0, because factorial 0 is 1. Comments. Okay. Now let us add the condition here. This will be a recursive call. N into the same function, factfunc. So function inside a function, n minus 1. Okay. And semicolon. This is our recursive call. Let us now call the function. It is having a return type int. So we will pass the value now. Let's say 7 factorial. So this will be passed. And printf the result. %d for the number, that is format specifier for the integer. And the return value. Now it looks fine. Save. Right click, run. Okay, it printed the output correctly, but it is showing a warning. So to fix this, just before int main, we can set the function prototype like this. Let's see now. Right click, run. Now you can see there is no error. So in this way, guys, we can find the factorial of a number with recursion. The main function calls the factfunc function to compute the factorial of 7. The result of the function call is stored in the variable res, which is then printed here. If the value of n is 0, the function returns 1 because factorial 0 is 1. If n is greater than or equal to 1, the function returns n multiplied by the result of factfunc n minus 1, effectively breaking down the problem into smaller subproblems until it reaches the base case. So these are the recursive calls. Okay, first the value of n will be multiplied with the factfunc n minus 1, that is 7 minus 1, 6. This is recursion. Then in the next recursive call, the value is currently 6. Okay, so in the next recursive call, it would be the last one into factfunc n minus 1, that is the value of n was now 6. Therefore 6 minus 1 5. In this way the recursive call goes on, and in the end we will get 7 factorial 5040. So in this way recursion works in C. So guys, we saw how to work with recursion in C language. We also saw an example. Thank you for watching the video. In this lesson we will understand what are structures in C language. We will also see some examples. Let us start. A structure is a user-defined data type in C language. In this lesson first we will see what are structures, then we will define a structure, and also learn how to declare a structure in two ways. After that we will learn how to access structure members, and in the end we will see an example of structures covering the above concepts. So let us start. Structures in C allow you to group variables of different types together under a single name. This is useful for creating complex data types that represent real-world objects or entities with multiple attributes. With structures you can easily store variables of different types such as int, char and others. This is quite different from arrays, right? Because arrays store data of similar types, like we saw in the previous lessons. We stored the marks of students which were in integers, but with structures you can store data of different types. Here is an example, like storing the details of employees. The employee name, age, zone, salary are from different data types, like name is a string, age is an int, zone is a string like north, east, southwest, salary is a float. So all these you can store in a structure at a time, unlike arrays. Now let us see how to define a structure in C language. The struct keyword is used in C to define a structure. We just saw an example to store different types. The same example is here, but it will get stored in a structure. You need to name the structure, like we have named it as EMP here. Write the keyword struct, then space, and after that mention the structure name. Here it is EMP. Within that you need to declare your variables. Okay, these are called structure members or fields. Like here we have name, age, zone and salary. So this is how you can define a structure in C. We saw how to define a structure. Let us now see how to declare a structure. In C you can use the following two methods to declare a structure. First we will see how to declare a structure while defining it. Then we will declare a structure with the struct keyword. Let us see the first way. The first way is to declare a structure while defining it. So we just saw this example. First we added a name to the structure. Then we included 4 members. So to declare it, you can directly mention the variables, like here we have named them E1, E2 and E3 so that we can access the values. We will see an example later also. Just outside the curly braces, you need to mention the variables. This was the first way. The second way is to declare a structure with struct. Our variables were E1, E2 and E3. Okay, so here we have declared a structure. Here instead of directly writing it after the curly braces, we have declared it separately. Like here we have shown struct space the structure name, and after that mention your variables. So these were the two ways to declare a structure. Let us see how to access structure members. In C you need to use a period, that is the member access operator. Call it as a dot. You need to write the structure variable dot the structure member. This is the syntax. For example, Let's say you want to access the record of the first employee. So use your variable E1 and then the structure member. Let's say the member you want the name. So you'll write E1 dot the same member for name, that is dot name. Similarly for age, E1 dot age, for zone, E1 dot zone, and for salary, E1 dot salary. Now we will see a complete example to create a structure. We will declare and define a structure. We will also add variables and learn to access structure members in C. Let us see the example on VS Code. Here is our VS Code. Here is our Amit project folder. We added all our C files here. Let us create a new file. Right click, new file. Demo37.c. We will add a comment. Now add the header file with the main function. Now let us create our structure. Okay, above the main function, let us create our structure. The struct keyword, the name of the structure EMP, and within this mention the structure members. First I mentioned the name, then the age in integer, after that the zone, and in the end the salary in float. Okay, so these are 4 members. Now we can also add the variables here like this, like I have shown before, or we can also set it in the main function. Now let's say we want to declare and initialize also. We want to set the information of the first employee, so I'll mention struct emp E1. Okay, and then I'll set, let's say, the name David of the employee, age 30, zone east, and then the salary. Now we will print it. Employee name will be in %s format specifier. I hope you remember. /n and then E1 dot name. It is automatically showing. That means everything is working fine. I'll copy this and paste it 3 times more for our data. Okay. Let me add return. Now I'll change it, employee age, employee zone, and employee salary. Okay. Employee age I'll set, zone and salary. Age was integer, so %d. Zone was string. Salary was float, so %f. That's it. Now when I'll run it, it will display me the record of the first employee. File, save, right click, run. Here it is showing us the values. Here we have also used the member access operator to access structure members. Here we accessed all the members, name, age, zone and salary. The variable was E1. Okay, so we have shown this here. The same. Here you can see we can change this. I'll write %.2f. That is 2 places after the decimal. Save, right click, run code. Now it is fine. Guys, we saw what are structures in C language. We also declared and defined them. and also saw how to access structure members with an example. In this lesson, we will understand what are unions in C. With that, we will also compare them with structures and also see some examples. Let us start. So a union is a user-defined data type in C. First, we will understand what are unions. Then we will see the difference between structures and unions because they are quite similar. After that, we will create a union and see some examples. In the end, we will learn how to access union members and see some more examples. In C, a union is a user-defined data type that allows multiple members to share the same memory location. This means that a union can store different types of data, but only one type at a time. These are useful when you need to work with different data types in the same memory space, and they help save memory by overlaying different data types on the same memory block. And these are often used in situations where memory efficiency is critical, such as embedded systems, hardware interfacing, communication protocols, and others. When you need to work with different data types but only need to store one type at a time, use unions. The size of a union is determined by the size of its largest member. We will see the examples later. Also, you can only access the value of the member last assigned. Previous values are overwritten in unions. Structures and unions are quite related to each other. Let us see the difference. As we saw in the previous lessons, structures allow you to store data of different types. Even union allows you to store data of different types, but the memory for the declared variables in a union is allocated to the largest memory. This is quite different with structures. The memory for each declared variable in a structure is allocated to each variable name, and in union, as I said, is allocated to the largest memory. The size of the structure is calculated by adding the sum of its members, but the size of a union is the size of its largest member only. Then how to access members in structures and unions? You can access individual members at a time in structures, but in union you can access only one member at a time. The keyword for a structure is struct and for a union it's union. Now let us see how to create a union. Since you already know what is a structure, you can easily relate. We used the union keyword. In structure we used the struct keyword. Type the keyword union, after that the name of the union. Here we have added the name demo. After that we have used the curly braces to add the union members. Here the union members are A, B, C and D. Just for an example, integer is A, float is B, integer is C, and the array of characters, that is string, is D. So these are the union members and the name of the union is demo. We will now see a live running example. Let us create a union and understand how many bytes of memory gets allocated. The largest member of the union would be double here. The size of the double type is 8 bytes. Therefore 8 bytes of memory gets allocated and the output would be 8 only. After that we will also modify the same example and change one of the variables to understand the concept of unions. Let us see the example on VS Code. Here is our VS Code. We added all the codes in the Amit project folder. Let us create a new file. Right click, new file, demo38.c. Okay, let us add the comments as well as the header file. Now I'll create a new union space demo. Demo is the union name. Now I'll add the union members. Just for an example, different types. Okay, float, this looks fine. All 4 different types. And I'll close this. Then use the main function and I'll just print them to understand how many bytes are allocated. I told you the largest is what union focuses. So here the largest is the double, right? Out of the 4. Int, float, double and char. So the double is the largest with 8 bytes. The size of double is 8 bytes. Okay, so just print. So the size of union is the size of the largest member. Here it is double. So I'll just print size of union %d. So we will use the size of operator. So it is used to determine the size in bytes of a data type or object. Within this, I'll mention the union name. Okay, like this, union space demo. So this will give us the size of the union, which will be the size of the largest member. Okay, that is double. Return 0. We will also change this code later. We miss the semicolon. File, save, right click, run. So here the size of union is 8. Why? Because the size of double is the highest one out of the others, like from int, float, double and char. Since it is 8, so the size of the union is always the size of its largest member. Therefore the output here is 8. Now I'll do some changes. I'll just comment this and change this to a string by adding array of characters. Let me set it to 20 and let's see what will happen. File, save, right click, run. Now the size of union is 24. Integer was having size 4, float was having size 4, double was having size 8. Now we added an array of characters. Now the largest member is the char array because it occupies 20 bytes. Okay. As I said, the size of the union will be the size of this largest member. And the compiler also adds some padding for alignment purposes. Therefore the output is 24. So 20 bytes here is for char D20 and the rest of the 4 bytes to make it 24 is padding added to make the total size a multiple of 8 bytes, aligning to double's requirement. So the total size is 24 bytes, accounting for the padding needed to align the union to an 8 byte boundary. Now let us see how to access union members in C language. We use the same member access operator, which we also worked around in structures. Now let us see an example to access union members in C. In the example, the largest member will be the char T, that is our array of characters. Therefore the output will be 24 like we saw before. In this, the rest of the variable values will get corrupt. We will also modify this in the same example by editing the code. Let us see the example. We will create a new file in VS Code. Right click, new file, demo 39.c. Okay. Access union members in C. This is our command. Add the header file. Now we will take the same union, copy, right click, paste. Okay. Now let us access the union members using the member access operator. So here I'll use union space the union name Here we will mention the union variable, that is, let's say demo. You can add any name. Using the same we will access like demo.a. We will add some values. Demo.a is equal to 5, demo.b is equal to 15.6 because it is a float. Demo.c is our double, so I'll mention the values, let's say this. And for the string, let us use strcpy, that is copy, to copy the string in demo.d. Okay, that's it. Now we will print it. I'll just edit this. Let's say data.a. I'll add first. Okay, here directly I'll print demo.a. Right click, copy, and I'll paste. So we have 4 union members. For them I have added these C and D. Okay, also in the end I'll print the size of the union. That's it. Okay, now let us print and understand. Go to file, save. Now what should be the output? The largest member of the union here is char D20. Therefore the bytes of memory get allocated and size 24 will be visible for the largest D variable, the following variable. Okay, that is here, the following variable. Right click, run. Okay, we have used strcpy, therefore string.h, and also add the slash n. Okay, and also the format specifier. The first one was an integer, so %g. The second one was a float. Third one was double, I told you, lf. And fourth was a string, %s. And the size of union in integers, that is d, %d. Run. We ran it. Okay, here the largest memory occupied by the variable will get considered for the memory allocation. Okay, therefore first the size of union is 24. We also saw in the previous example regarding the padding extra 4. Since variable d is 20, for that 8 byte calculation it added 4 extra, that is 24. It also printed fourth correctly, that was a string, the demo text. Now the third is corrupted. Rest of them you can't understand since those got corrupted. How you can fix this? It's very easy. We can fix this by working on one variable at a time. Okay, so let us see. I'll just copy this, cut and paste here. You can also use Ctrl X to cut and Ctrl V to paste. Add for demo dot B. Do the same for others. And the fourth one. Now let us see the difference now. It will get completely fixed. Let's see. File, save. right click, run. Now you can see we fixed it. The first one was 5. It printed it. The second was 15.6. It printed it. We can also add dot 2 here to get only 2 digits after the decimal. Here we printed the long float. Okay, we can set dot 3 here. LF was for double. Then the last one was a string and it printed it. And the size we already know why it was visible. So in this way guys, we can work with the union members in C. We also fix the issue by working on one variable at a time. So guys, we saw what is a union in C language. We also understood how to declare and define it. With that, we also accessed union members with examples. Thank you for watching the video. In this lesson, we will understand what are pointers in C language. We will also see its advantages and disadvantages with examples. Let us start. Pointers are a fundamental feature in C programming. They allow you to directly manipulate memory and perform various advanced programming tasks. A pointer is a variable that stores the memory address of another variable. Instead of holding a value directly, a pointer points to the location in memory where the value is stored. To get a memory address of a variable in C language, we generally use the AND operator. The AND, that is the ampersand sign, is an address operator in C language. It is used to access the address of a variable. In pointers, we generally use the address operator as well as the indirection operator. Address I already discussed. The indirection operator is the star sign, that is the asterisk. It is used to access the value of an address. So while learning the concept of pointers, both of these operators are quite important. Let us first see the advantages of pointers. It directly accesses the memory and hardware, which in turn enhances the performance. It enables the dynamic allocation and deallocation of memory. So these techniques avoid wastage of memory. Pointers are a fundamental feature in C to create complex data structures like linked list and trees. Through function pointers, callback functions are allowed that leads to better modularity in code. Modularity enhances readability, leads to easier maintenance and reusability of a code. Let us see the disadvantages. It is complex. Sometimes it is complex to understand. You can also face some debugging issues, like memory leaks are sometimes difficult to debug. It can also lead to buffer overflow if it is not used correctly. It can lead to memory leaks if the memory is not freed. I just discussed about the operators used in C language for pointers. So using one of them, let us display the addresses of variables before moving further. Here is our VS Code. We created a folder with all our codes. Let us create a new file. Right click, new file, demo40.c. Let us add the header file and the main function. I'll take 3 variables: integer variable A, float variable B, and char variable C. Now I'll print their addresses. Address of variable A is equal to, here I'll use the format specifier %p. This is a format specifier to display the address. Now write and A to get the address, and is the ampersand sign. that is the address operator. Similarly do for others. Copy and paste. Now change B and C. We will also add /n and here I'll change. Also set it to P. Now it looks fine. Go to file, save, right click, run code. Here it is. We have displayed the address of variable A, B and C using the address operator. Now here is the syntax of pointers. We already saw how to display the address. So the following is the syntax. First you need to write the data type, then the name of the variable. Here star is visible, that is asterisk. The var name can also be considered as the pointer name or the pointer variable. Let us see some examples. So here we will see how to declare and create a pointer. So this is the example. You can compare it with the syntax. In the syntax we saw that the star, that is the asterisk, is followed by the pointer name, that is the pointer variable. But in the example we have shown something else. So we need to remember that both are correct, both are syntactically correct. In the example we have considered the data type int. Therefore this is pointer to an integer. We are declaring a pointer to an integer. You can add the asterisk after int or even before a, like the same is visible here. Let us implement this on VS Code and understand it more. We will create a pointer variable and point to an integer variable. Okay, that means a pointer variable B will store the address of the variable A. Let us see. Let us create a new file. Right click, new file, demo41.c. Let us add the comment, create a pointer in C. Add the header file. Now the main function. First I'll take an integer variable and I'll assign a value. Okay. After that I'll take another variable and assign the address. So what I'm doing here pointer variable B is storing the address of the variable A. Okay, so this is what we created, pointer to an integer. We saw in the syntax also before. Okay, A is our integer variable and this means that B is a pointer to an integer and it is being initialized with the address of A. Now B is a pointer to the variable A and it holds the address of A. Let us print. First we have printed the integer value. Now we will print the address of A. Using AND A. And what will be the format specifier? %P. And here I'll use the address operator, right? AND A. Address of A using pointer B. Okay, so what it will be? First the format specifier, then the B. So here we are printing the value of B, which is now having the address of A. This is /n for next line. Save, right click and run. So here what you can see, the address of A and the B are having equal addresses because the pointer variable B stored the address of the variable A, that is the following. So both are having the same addresses. I'll just remove this. Now it's fine. Go to file, save and run. Now it's fine. Okay. These are pointing to the same address. Both of them are having the same address. Also here we are printing the integer value. So I'll set it to D. Okay. Run. Now this looks perfect, I guess. Integer value 10 and both of them are having similar addresses. So guys, we saw what are pointers in C language. We also saw the advantages and disadvantages. We created a pointer and also saw how to store the address of the other variable with pointers. Thank you for watching the video. In this lesson, we will understand what is an enum in C language. We will understand its purpose and how to create it in C language with an example. Let us start. Enum is a user-defined data type in C language. Enum is short for enumeration in C. We will first see what is enum, how to create an enum, how to create an enum variable. With that, we will also assign a value to an enum variable. We will also run an example. Let us start. Enum in C consists of a set of named integer constants. It is used to assign names to the integral constants, which makes the code more readable and maintainable. That is, use enums to name constants. The enum keyword is used in C to create an enum. Here is the syntax. You can relate the syntax with structures and unions also. Write the keyword enum. After that, the name of the enum. And in curly braces, you need to mention the enum items separated by comma. And in the end, you need to close the braces with a semicolon. Let us see how to create an enum. So let's say our enum name is directions and the enum items are north, south, east, west. Just write the keyword enum, after that the name of the enum, that is directions here, and within curly braces mention the enum items separated by comma. In this case, the enum items are 4, north, south, east and west. Okay, so this is how you can create an enum. We will run an example later. Let us see how to create an enum variable. To create, you need to mention the keyword enum, then the name of the enum, after that the enum variable. Here we have shown only a single variable D1. So this is how you can create a variable in enum. Let us see how to assign a value to the enum variable. You can begin the assignment with the value 0, and this is also the default. It increases by 1 for each subsequent enumerator. That means beginning with 0, it goes to 1, then 2, 3, 4, 5, and it goes on based on your enum items. Also, you can assign custom values to the enumerators. It is not mandatory to begin with 0. Now let us see an example to create an enum in C. So this will give you a brief overview of how to create an enum, how to assign values to it, and all other details. Let us see. Here is our VS Code. We created Amit project folder for all our C files. Right click and click new file. I'll give it a name demo42.c. Add a comment enum in C. Okay. Add the header file. Then let us create an enum using the enum keyword. Add the enum name. I have added directions. And I'll just add the enum items: north, south, east, west. I'll close it with a semicolon. Now let us add int main, that is the main function, and within that I'll create enum variables. I told you how to create. Similarly, type the keyword enum, then your enum name. After that, we will create two variables, d1 and d2. Okay. Assign the value. d1 is equal to north, it is showing, and print the value of d1. I'm setting it to %d because it will display a constant. By default it's 0, so it will assign 0 to the first variable. Okay, now for the second variable I'll copy and paste. d2 is equal to, let's say I'll set south, so I'm assigning a value to the enum variable d2. That's it. I'll return and let us display. File, save, right click, run. So you can see it is showing 0 and 1. I told you that by default it begins with 0, then it increments. So in this case it incremented to 1. If we'll print d3, it will go for 2. For d4 it will go for 3. In this way it will increment based on your enum items. So guys, we saw what is an enum in C language. We understood the concept. With that, we also saw an example to create an enum. We also created enum variables and values were also assigned to the enum variables. Thank you for watching the video. In this lesson, we will understand what are storage classes in C. We will also see the types of storage classes, and in the end we will run an example. Let us start. Storage classes in C determine the scope, visibility, and lifetime of variables and functions within a program. There are 4 storage classes in C: auto, register, static and extern. So let us understand them one by one before running an example. The default storage class for local variables is auto. Variables are allocated memory on the stack. Variables are initialized automatically with garbage values. The scope is local to the block in which they are defined, and it exists till the control remains within the block. Now let us see what is a register storage class. It is similar to auto but suggests to the compiler to store the variable in a register for faster access. The variables must be of type int, char, short, or their unsigned versions. The scope is local to the block or function where it's defined, and the lifetime is only during the execution of the block or function. Let us go to static. Under static storage class, the variables retain their values between function calls. Variables are initialized only once at compile time. The scope is local to the block in which they are defined, that is if defined within a block. For global variables and functions, the visibility restricts to the file where it's defined. So its scope is local as well as global. It is local to the block in which they are defined. It is global if defined outside all blocks. The last storage class is extern, that is external. It is used to declare variables that are defined elsewhere in the program. Variables must be defined outside all blocks. The scope is global, that is across multiple files, and it will exist till the program terminates. Now let us see an example to implement all these 4 storage classes in C. Here is our VS Code. We created the following folder and added all our programs in it. Let us create a new file. Right click, new file, demo43.c. Let us add a comment. Storage classes in C. Let us add the header file. Now let us begin. First we will set a global variable. Let's say the name is global var. We are creating an integer variable. We will assign it to 0. Default storage class for global variables is extern. Okay, now we will create our function void. Let's say the function name is demo function. Within that we will create 3 variables. Int local val is equal to 0. We will assign it to 0. Then another integer variable, we will assign it to 1. Then the static variable, we will assign it to 2. Now we will set it to auto. The second one would be with the register storage class, and the third one will be static. Okay, now let us print within the function. Okay, let's say local var is equal to %d, and I'll also add a /n new line, and similarly I'll print rest of them. Copy, paste, and in a similar way. Okay, so we have printed all of them. Now we have printed all 4 of them. Now it looks fine. We will now increment them one by one to understand the concept. Okay. Now the main function, for loop int I is equal to 0, I is less than 3, and I plus plus. We will call the function. Here it is. Return 0. Now let us run it. File, save, right click, run. Now what happened? Here it printed. I'll add a /n here. Okay. Save, right click, run. Now here it is. Let us understand the output. Here local var is a local variable. Okay, with auto storage class, that is this. So it will get reinitialized every time the function is called. So it's 0 when the function is called again, it's again 0, and it's again 0 here. That means it got reinitialized every time the following function is called. Okay, 3 times 0, 1, 2, I is equal to 0, I is equal to 1, I is equal to 2. 3 times. Now let us move to the second, that is the following. It was having register storage class. So you can see register variable was having 1, then again 1, and in the next it is again 1. So it is a register variable intended for quick access, and it also gets reinitialized every time. Then came the static. Static var retains its value between function calls because of the static storage class. So what will happen? It was 2 initially. In the next call, here it is now 3, and in the next it is 4. So it retained its value and got incremented. 2, in the next call it is 3, and in next it is 4. The last one would be our global. Okay, the default storage class for global variable is extern. Global var is a global variable with external storage class, and it retains its values across the entire program. So it was 0 initially. In the first call it is now 1, and in the last function call it is 2. So this is how we can understand the 4 storage classes in C language. 2 of them retain its value and 2 of them gets reinitialized every time. So here we saw that we have local variable here, and we are incrementing them using this, and here are the function calls under a for loop. Okay, when the program will run, initially the value of local var is 0. Since local var is with auto storage class, it gets reinitialized every time the function is called. So it is 0, it will increment, but when the function call will happen, it will reinitialize and remain 0. In the next function call it's 0, and in the last also it is 0. Then comes your register variable reg var. It is similar to auto and gets reinitialized every time. Okay, it's 1 right now. It will increment, but it will reinitialize with every function call. So it will be 1 again. It will reach here, then it will increment and 1 again. Therefore, it's 1. In the next function call it's 1, and in the last function call it is 1. Okay, then comes your static. Static retains its value between function calls because of the static storage class. It is 2 here. It will increment and will go 3. Then again function call, it will again print and go to 4. Similarly the things will go on. Initially it is 2, it got printed here. Then it incremented with 3 and then 4 because it retained its value. Now the last one, global variable, which was 0 initially. It is with the external storage class because the default storage class for global variables is extern. It retains its value across the entire program. It was 0, it printed 0, then it incremented, and in the next function call it printed the incremented value. Then it incremented again, and the next function call, things went on like this. Global variable was 0. Then it incremented to 1. After that it incremented to 2. So guys, we saw what are storage classes in C. We also understood the types of storage classes. We also ran an example to understand the concept. Thank you for watching the video. In this lesson we will understand how to handle files in C language. We will create a file, write text to it, and will also read it with examples. Let us start. So let us understand how to handle files in C. First we will see what is file handling. Then we will create a file and also learn to close it. Then we will write to a file and in the end we will read the same file. File handling in C is a crucial concept, especially when you need to store data permanently on a disk. It involves creating, opening, reading from, writing to and closing files. To work on files in C, we have the fopen method that is part of the stdio.h header file. If you want to use it, you need to declare a pointer of data type file. A file pointer is used to keep track of the current position in the file. Here the syntax is visible. We have used the fopen method. It is used to open a file. After that, you need to mention your file name, that is the file path, and then comes your mode. So the file mode is represented by a single character, that is to read a file, mention R, to write to a file, mention W, and to append a file, mention A. You need to mention this after the file name. So this was the syntax of the fopen method to open a file. Let us see how we can create and close a file. We just saw the fopen method, so the same method is used to create a file. But initially you need to mention the mode W. Also you need to close a file you open. For that, use the fclose method. So here we are taking an example of a file, myfile.txt, in the E drive. Remember that you can create a file in any drive, whether it's D, E, F, okay. Also you need to use the backslash for the path. Remember on VS Code, you need to use the double backslash for the path. So let us first see an example and create a file in C language. We will open and close a file. Here is our VS Code. We added all our codes in the Amit project folder. Let us create a new file. Right click, new file, demo44.c. I'll add the comment. Create and close a file in C. Let us add the header file. So we only need to mention this, the following header file, because fopen, that is the methods related to file handling, is a part of the stdio.h header file. Okay. Mention the main function. Now I told you the file pointer. This file pointer keeps track of the current position in the file. Now we will create a file. I'll give it a name, myfile.txt. The pointer, we will use the following. Now write fopen and within this mention the path. So a file will create in the following path. Let me first create a folder. So here I'll go to E drive. Now create a folder Amit. Right click, new folder. I'll name Amit. Now your file will get created inside it. Following is the path E Amit. I'll copy and I'll paste it. After that I'll mention the name of the file I want. So it is myfile.txt. So I told you in VS Code you need to add double slash. You can see the color difference. Okay, so I'll add double slash and it will work. Now our file will get created in the Amit folder. I told you we need to close the file. So we will use the fclose and mention the fp in it. Here the following fp is a pointer to a file object. Okay. In C, when you work with files, you use file pointers to keep track of the file and the current position within the file. This file is a data type defined in the standard input-output library, that is stdio.h. This is used to represent a file. The asterisk before fp indicates that fp is a pointer to a file object, and fp here is the name of the file pointer variable. Okay, that is the following: semicolon and return. File, save. Okay, now here can you see any file? No. Under E drive, Amit, it will get created. I'll run, right click, run. Now after running, I'll go to the same path, and now you can see my file.txt created with no text, 0 KB, because we just created it. Okay, in this way guys, we can easily create a file in C language. The file is empty since we did not add any text to it. We created this file in the E drive folder. The folder is Amit and the size is 0 KB. Now we will write to a file using the fprintf method. To write, you need to first open the file in W mode. I already told you about the modes. It's a single character. So to write, just mention W. We need to set the pointer in fprintf and also the text to be written to the new file myfile2.txt. So we are here creating a completely new program and a new file myfile2.txt in the same folder. So let us see. Now I'll create a new file. Right click, new file, demo45.c. Okay, write to a file in C. I'll take the same program. Okay, right click, copy, right click, paste. Now what I'll do, this is similar, the file pointer. Now I'll open a file. So this file would be myfile2.txt. Okay, as you can see, it does not exist, so it will get created. After that, we will write. After that, the file pointer and then the text. That's it. I'll save. So we need to also close it. That's why fclose is written. We already discussed that. Okay, it should be fprintf. File, save, right click, run. Let's go here. And now we have our myfile2.txt. With the text, this is the demo text. Let us open it. You can edit in Notepad or Notepad++. Let's say I'll open in Notepad. So this is the text. Okay, we added the text. This is a demo text in the file myfile2.txt. So in this way guys, we can write to a file. So guys, we successfully created the myfile2.txt file and added the text. This is a demo text. Here the file is also visible, myfile2.txt, in the same Amit folder. Now we will see how to read a file in C language. To read a file in C, use the fopen method with the mode R. So here the mode is R, that means read. And you need to close the file in the end. What we will do here, we will read the second file which was having the text. This is the demo text. We will print the same text to the console, that means reading the file. We will create a new program and use the same file myfile2.txt and read it. Let's see. I'll create a new file. Right click, new file, demo46.c. Read a file in C. First we added the header file, the main function. We will use the file pointer. We already discussed about this. fp is equal to fopen. We will open the same file, okay? I'll take the code from here. Copy. Paste. Okay. Now what we will do? We will use R mode. Open a file and read with the mode R. Now we will read the file. Create a while loop. We already discussed while loop in the loop lesson. Use fgets and within that mention the following. Now what is this? This is a variable. Okay. str is our character array. This will store the content of the file. Okay. Here we have used fgets. The fgets is used to read a string from a file. It reads up to n-1 characters from the file stream and stores them into the buffer pointed to by str. Here str is a pointer to a character array, the following, where the read string will be stored. I should mention 30 here. The following is the maximum number of characters to read, including the null terminator. The following is the pointer to the file object from which to read, that is the following. So we will read a line from a file using this. So we will just print it. Since it is a string, we will use %s and str, that's it. This will read the file and display. Okay. Close the file using fclose. That's it. Now what will happen? This is the demo text will print on console. Let us run, right click, run. This is the demo text printed. Okay, that was the content of this file. So in this way guys, we can read a file in C language. We have used fgets method for it. In this lesson we saw what is file handling in C, how we can create a file, write to a file and read a file. Thank you for watching the video. In this lesson we will learn what are math functions in C language. With that we will also see some examples. Let us start. If you want to perform mathematical tasks like finding the square root, returning the sine, cosine, tan or hyperbolic sine, cos, tan, then use the math functions. C language is having a separate header file for the math functions, that is math.h. So if you want to work with the math functions, include math.h in your program, like #include math.h. Now we will see some popular math functions. With that we will also learn about its usage with codes. So let us start with the square root. If you want to find the square root of a number, then use the sqrt function in C language. Let's see them one by one. Here is our VS Code. We added all our codes in the Amit project folder. Let us create a new file. Right click, new file. Demo 47. First we will see the sqrt function in C. I'll add the header file. and the main function. The sqrt function in C is used to get the square root of a number. First, let us take a number. We will consider it as a double type and we will directly print it. While printing, we will mention the sqrt function. Square root of, for double we have %lf format specifier is %lf. The output will be in the same type. This is your number A and the last one is your sqrt function, and within that we have mentioned the value. So this will find the square root of A, that is square root of 25.0. Now it looks fine. Save. Okay, and to use sqrt we will add the math.h, else there will be an error. Let us run. Go to file, save, right click, run. We ran it and you can see the square root of 25.0 is 5.0. If you want to reduce the number of digits after decimal, you can mention this. Let's say .3lf. I'll save and only 3 digits will be visible. Here it is. Okay, in this way we can work with the square root function to calculate the square root. Now we have 10 more examples. So I'll quickly create files and also mention the comment and these 2 header files which are required. So let's do it. Guys, we have created all the files. Now let us move to the second one, that is the exp method. Here it is. We already added the header files. Let us add the main function. The exp function in C is used to return e raised to the power of a. So let us see. First we will create a variable, double variable 2. So we will find e to the power of 2. Okay, I'll print exp means exponential value. The exponential value of lf, this is the format specifier for double, is equal to lf. Now here we will add a and then the exp in bracket we will add a. This will return e raised to the power of a. Return. I'll go to file, save. We already added the math.h header file, so there won't be any error. Run. Here it is. The exponential value of 2 is 7.38. This means we calculated the value of a raised to the power of 2.0 here. Okay. Now let us see the next example. Cos function in C. This function is used to return the cosine of a. Okay, we will convert the angle from degrees to radians before passing it to the cos function. Let us add the main function. We already added the math.h header file. Now here first we will use hash define. Here I'll tell you the purpose. We will take the value of pi as 3.14159265. So what is the purpose? The hash define is a preprocessor directive used to create symbolic constants. It allows you to define a constant value that can be used throughout your code. So we have defined it here. So later on if we want to use it, we can directly use pi instead of the complete number. Okay, so this is the purpose. And we all know the value of pi is 3.14, so we don't need to write this completely. We will just write pi using the hash define preprocessor. Let us take a variable a, double a is equal to 30.0, and we will also take a res variable, that will be the result. Now let us convert the angle from degrees to radians. So this is the formula: a into pi divided by 180, and in result we will mention the value of cos A. Okay, this A, which is converting the angle from degrees to radians. That's it. Now let us print cosine of 30.0 degrees. We can also write converted to percentage LF radians is equal to percentage LF. After that, mention A and RES. Okay, so we calculated the cosine of A. I'll go to file, save, right click and wait, we missed the return. Okay, go to file, save and right click, run code. Here it is, the cosine of 30 degrees, which is converted to 0.52359 radians is equal to 0.866025. So in this way we can find the cosine. Now let us see the next example. To find the sine function, first we will take hash define like we saw before. Okay, now we can take the code from here because we want sine now. Right click copy, right click paste. The method is similar. I'll change it to 60. The RS variable for the output. Here also we are converting the angle from degrees to radians. So in the sine function we are returning the sine of A. Here we have converted the angle from degrees to radians before passing it to the sine function. Okay, that means here we are converting from degrees to radians and then we have passed it here. Sine of 60 degree converted to radians is equal to ARES. Same. Return. Okay. Now we will get the sine of A, that is the sine of 60 degrees. Right click, run. Here it is. Okay, here the value is 5, not 4. Okay, we will run. We will save and run. So this is the value, exact value. Okay. We should also fix it for the previous program. It is fine here, I guess. And this looks fine. Okay. Here is the output. So we have used the sine function in C to return the sine of A. A was 60 in this case. First we converted the angle from degrees to radians and then we added that to the sine. Now let us see the next example. Here we will find the tangent of A. The tan function in C expects the angle to be in radians, not degrees. So we will convert the angle from degrees to radians before using the tan function like we saw before. So I'll take the code from here. Copy, paste. The steps are almost similar. Double value, let us keep it the same. Now we will convert the angle from degrees to radians, that is here, and after that we will use tan. Tangent of or tan of 60 degrees, okay, is equal to, I'll just print the result. Save, right click, run. So the tangent of 60 degrees is equal to 1.73251. In this way we can find the tangent of A. Now the next function, A cos. The A cos function in C returns the arc cosine of A in radians. So we will calculate the arc cosine of A and convert from radians to degrees. Let us see. I'll write the main function. Before that I'll mention the value of pi using hash define preprocessor. I already discussed that. So let us take this, copy and paste. Now under the main function we will take a double variable A and give it a value and a res variable to get the output. Now let us calculate arc cosine of A and convert from radians to degrees. For that use the resultant variable res, mention A cos and within this the value of A. Then to convert it, multiply it by 180 and divide by pi. That is the following value. Okay, I'll print now arc cosine percentage LF is for double is equal to percentage LF degrees because we converted it to degrees. A and the value of res because it is having the output. That's it. Now I'll go to file, save, right click and run. Our output will be in degrees. Here it is, arc cosine of the value is equal to 107.457603 degrees. Okay. In this way we can find the arc cosine. Now the next arc sine. So let us take the same code. Similarly what we will do, we will convert. We will calculate arc sine of A and convert from radians to degrees. Okay, this is radians. Rest we will keep the same. Here it is calculating A sine A arc sine LF is equal to LF degrees. So the output is in degrees using the A sign. We will return the arc sine of A in radians using this, but in the complete step we are converting from radians to degrees and then printing the degrees because the output will be in res. Save, right click, run. Okay, this is fine now. Right click, run. Here is the output. The arc cosine is equal to minus 17.457603 degrees. In this way we can find the arc sine. Now let us see the next, which is A tan. I'll take the code from here, copy, and we will find the, and we will return the arc tangent of A in radians, but we will convert the arc tangent of A. We will calculate the arc tangent like this, and then we will convert from radians to degrees. Okay. So here it is, we are calculating. Let us go to file, save, right click, run. Here we have the output. The output is 16.699244 degrees. Okay. Now let us see the next code. The next set includes your hyperbolic. The first one is hyperbolic cos. Using cos h, we will return the hyperbolic cos of A. So I'll write it int main. We don't need the pi in it. First we will take the value double A is equal to 2.5 and an output variable, that is res. Under the output mention the value of A here to return the hyperbolic cos. Mention cos h and then print it. Cos h is equal to percentage LF because we have double here, and after that mention is equal to percentage LF a res. Okay, return, right click, run. So the output is 6.132289. I'll just change it, cos h. Okay, this looks fine. File, save, right click, run. Now this looks fine. Okay, cos 2.5 is the following. So in this way we can return the hyperbolic cos of a. The next example is sin h, that is hyperbolic sine of a. I'll take the same code. Okay, now we have the value double, the double variable as 2.5, and here we will add sin h to return the hyperbolic sine of a. Here is the res and here we have sin h, that is hyperbolic sine, and we have printed the result. File, save, right click, run. So the output is the following, 6.050204, that is sin h 2.5. So in this way we return the hyperbolic sine of a. Now the last example, hyperbolic tangent. Okay, I'll take the same code, copy, paste. Here we will add tan h for the hyperbolic tangent. The value of a is similar and we will find out tan h. Printed the output, save, right click, run. So it calculated the hyperbolic tangent of 2.5 and displayed the result as 0.986614. So in this way we understood the tan h function also. So guys, we saw what are mathematical functions in C language. To add it in your program, use the header file math.h, and we saw some popular mathematical functions also. We coded and ran 11 of those functions. Thank you for watching the video. In this lesson we will understand what are char functions in C language, that means character functions. Let us understand with examples. So if you want to work with characters in C language, you can use the character functions. Through these functions you can easily handle characters, like you can check whether a character is a digit, it is a letter, a new line, a space, even a punctuation mark, and others. C provided with a separate header file for character functions, that is ctype.h. If you want to work with the character functions, first include the header file in your program, just like you include any other header file, #include ctype.h. Okay. Let us now see some examples. Here are some popular character functions used in C language. Through this you can check whether a character is an alphabetic letter, digit, a white space, and you can also convert a character to uppercase or lowercase. Now let us see the example. We will begin with the isAlpha function. The isAlpha function will check if the character is an alphabetic letter or not. So let us run the code on VS Code. Here is our VS Code. All our files are in the Amit project folder. Let us create a new file. Right click, new file, demo58.c. I'll add the comments. isAlpha function in C. Okay, let us add the header file also. I hope you remember we need to use the ctype.h for the character functions. Now our main function, let us take a character. So I'll take, let's say, A, and now I'll check using the is alpha if ch is an alphabetic letter. Okay, for that I'll use if is alpha, in the bracket mention ch, that's it. If it is an alphabetic letter, let's say I'll print true, or I'll print percentage %c is an alphabetic letter. Okay, here I'll mention ch, correct. Percentage %c is for character, and mention else also, that percentage %c is, I just copied and pasted it here, percentage %c is not an alphabetic letter. Okay, let us run, return 0, go to file, save, right click, run. A is an alphabetic letter. Okay, so let's say A was 1. Now I'll run, right click, run. 1 is not an alphabetic letter, right? So this is how we can work with the is alpha. I'll again change it to A. Okay, or let's say P, run. P is an alphabetic letter. So through this we can work with the is alpha. Now let us see the next, that is digit. Right click, new file, demo59.c. Now we have is digit function in C. We will take the code from here, right click, copy, right click, paste. So here are the header files. ctype.h is for the character functions, and similarly we will just, let's say, mention 5 here, and here is digit and the character. Okay, is a digit and it is a digit. Okay, go to file, save. Now what will happen? 5 is a digit, right? It will print 5 is a digit. Okay, using the following is digit function. Right click, run. Here it is 5 is a digit. If you'll add a letter, it will go to the else. Right click, run. Here it is k is not a digit, obviously. Okay, now let's say I'll again change it to 8 and run it. Here it is 8 is a digit. Okay, so we understood the is digit function. Now the next one, right click, new file, demo60.c. Here we will check for a white space character using is space. So is space in C. I'll take the same, copy, paste. Okay, is space checks for white space characters, new line and others. So here I'll just add a white space. That means only a space. Check for white space. Is space, percentage %c is a white space, and here it is not a white space. That's it. Go to file, save. Now since it is a white space, it will go here and print percentage %c is a white space. That means That means a white space. Right click, run. Here it is. It is a white space. As you can see, nothing is visible, so we can do one thing. We can add it like this. Now the codes will be visible. Right click, run. I guess this looks fine now. This is the white space. Nothing in between. Right click, new file. Now the next example. To upper function in C. I'll take the same code. Okay, the header file for character, and within this I need to convert. So let's say I'll mention R in it, and I need to convert it to upper space. Convert to upper space using to upper. Uppercase of %C is equal to %C. CH of R is equal to upper CH. Now let us run it to understand. Save, right click, run code. Here it is, uppercase of R is equal to R. Small r, now the capital R. So in this way we can convert any character to upper space. Now the last example, right click, new file, demo62.c. Okay, in this we will see the to lower function in C. Similar method, but purpose is completely opposite. Here is the header file. Now I'll set it to, let's say, Q. Convert to lowercase of %C, and this is to lower. I should mention it like this, and for this also. Okay, this is the exact one. Now we will convert. The output will be small q. Run. Here it is, the lowercase of capital Q is equal to Q. In this way we can convert any case to lowercase. So in this lesson we saw what are character functions in C language. We saw some examples to check whether a character is an alphabet, digit, white space, and we also saw other examples. Thank you for watching the video. In this lesson we will learn what are string functions in C language. We will understand its usage and also see some examples. Let us start. So if you want to manipulate strings in C language, use the string functions. Using these functions, get the string length, copy one string to another, concatenate strings, and easily perform other operations. Manipulate and handle strings using the string.h library. So the string.h library is what we use in C to work with string functions. Just like you include any other header file on the top of the program, add string.h like this, #include string.h. Here are some of the most commonly used functions in C language to manipulate strings. Find the length of the string, compare strings, copy one string to another, concatenate strings, and perform other operations. Let us now understand these functions one by one. First we will return the length of a given string. Let us see on VS Code. Here is our VS Code. We added all our codes in the Amit project folder. Let us create a new file. Right click, new file, demo63.c, and first we will find the length of the given string using the strlen function in C. Let us add the header file first. For strings, we use the string.h header file. I'll add the main function. So first, let us get the length. First, I'll take a string. Let's say I'll add my name. Okay, and I'll find the length of this string. To find the length, I can take a new variable len, and within that I'll mention string length, that is strlen function, and mention str in it. So this will calculate the length, which will be integer. So just print len now, length of the string, and it will be %d, right? Because length is an integer. Len, that's it. Return, and I'll run it. Right click, run. And here it is, length of the string is 10. In this way you can find the length. Now let us learn how to compare two strings. Right click, new file, demo64.c. So to compare two strings, use the strcmp function in C. Okay, I'll take the header file from here. Now let us take two strings. First I'll take str1, and then I'll take str2, and within this I'll add nothing. I'll keep it empty. I'll add a space for 10 characters but won't initialize it. We will compare this. Let us take a new integer variable, result, and using strcmp I'll compare both str1 and str2. Now this will return a number. If the result is 0, that means both the strings are equal, else it will display it is not equal. So for that, obviously we will use if statement, if else statement. So if the result is 0, that means both are equal. Okay, else both are not equal. So that's it. Save, right click, run. What will be the output? Both are not equal. Here it is, both are not equal. So this method compared two strings and returned an integer. Now let us see the next function. Right click, new file, demo65.c. We will copy one string to another using strcpy function. Add the header file and the main function. Here first we will take two character arrays, that means string, okay, and then the second one, we have initialized the first to the string hello, and second we will keep empty, that is an empty character array. Now we will copy using strcpy. First mention the destination, and then the source. So str1 will copy to str2, str2 after copying. Okay, right click, run. Here it is, str2 after copying, it's hello. It was empty but we copied. So using strcpy, we copied the data from one string into the memory of another string. The first one was destination, I told you, and the second one was the source. Now let us see the last example. Demo66.c. We will concatenate two strings. Okay, using strcat. strcat function in C. Add the header files, string.h for the string functions and the main function. First we will take a character array, and here let's say I'll mention Amit. Okay, and then we will use the string concatenation. First mention the str, then what you want to concatenate. So I'll just concatenate my name. When I'll print, it will print my name. %s for string and just print str. And now str will include the complete name Amit and Diwan. This appends a copy of one string to the end of another. File, save, right click, run. Here the output is Amit and Diwan. So I concatenated it. So in this way we can concatenate strings in C. In this lesson we saw what are string functions in C language. We understood some of the popular string functions with examples. Thank you for watching the video. Guys, if you liked the video, you can directly go to our channel and support us by subscribing and joining. Click on the join button. Herein you can support us, okay, by clicking join here. And you can also go to any of our video, okay, herein click on the three dots and click thanks. You can also directly support us here, okay. Thank you for watching.